Right, morning, guys. I'm about to do a grade 9 maths paper 1. So let's please share the live if we have someone that we know who's in grade 9, struggling with maths, and they need assistance, whatever. I'll be going through like a full paper here. I'll be working it out. So you guys can invite those people. You can share the live with them. Remember that it's still early morning, I know, but it's only those people that really want something that will get up and go get it. So I'm just saying, let's get it. Let's invite them. Let people come. So I'm actually going to kick off this live lesson. But yeah, please do share it. Let's share it with as many people as we possibly can. Many people can benefit. Many people can benefit. Let's share the live lesson. Let's share it. Let's share it. Let's share it because it's about to go maths crazy. It's about to go maths crazy. And also let's double tap on the screen so that we're gonna have more people get exposed to the live and its content. Or let's power tap there, hungry power tap on the screen, so that we can get us and y'all prepared. So let's share this live far and wide with any grade 9 learner that you know, because we're going to be revising a paper here and we're going to be discussing certain aspects that are important. So let's share it out and afford any grade 9 learner who may need this lifeline, an opportunity to be able to be exposed. So let's share it out. Share it out far and wide. Share it out with everybody and anyone who would possibly benefit from a live lesson of this nature. As we'll be going through this paper, let's share it out. Share it with anyone, everyone, and anyone. We'll be doing a grade 9 paper shortly. So let's share it out with anyone that may need, so that when I start this live lesson, it can be of benefit to many people. So once again, about to start a grade 9 paper here. I'm gonna go through it, gonna answer it, gonna explain certain things. If you know someone who's in grade 9, it may be a niece, it may be a nephew, it may be a friend, it may be a neighbor, it may be someone that may have someone who's struggling with maths, and they'll be writing soon, or they'll be writing, I don't know, maybe in a week's time, maybe in 2 weeks' time. Let's share out the live to any grade 9 learner that could benefit. I'll be doing a grade 9 paper, maths paper 1 to be specific. So if anyone knows someone who may know someone else who needs this session, please let's share it out to any grade 9 learner or any grade 9 parent that has a grade 9 learner that may be struggling with maths or might be swimming the treacherous seas and is really struggling. Let's get this live out so that those people can benefit. So I'll be going through this paper and I'll be starting very shortly, and I'm just waiting for 2 more minutes. But definitely after 2 more minutes, I'll be starting this paper and we'll be doing a grade 9 maths paper 1. So let's share it out with friends. Let's share it out with anyone that may need to be hearing content like this. let's share it out, people. Let's share the live. Share the live with them. Yeah, because at the end of the day, it would be cool if they receive. Yeah, if they receive this, it's gonna be a good one. It promises to be a good one. Yeah, guys, please share out the live to any grade 9 learner. Share the live with grade 9 learners. Please share this live with grade 9 learners. All right. Yeah, today I'll be doing grade 9. Okay, I think from maybe 7:05 up until 9-ish, I'll do this paper. Then after 9, let's say around about 10, 9, 9:30, and I'll see if I can't do a grade 8 paper. All right, so today it will just be maths all the way. So share this with any grade 9 learner, grade 9 learners, or grade 9 parents. The grade 9 parents. Yeah, the tendency, guys, is that grade 9, I don't know, people tend to struggle with grade 9. And those people cool to do grade 8. Yes, I'll be doing grade 8 at 9 o'clock. At 9 o'clock, I'll be doing grade 8. So this morning, I'm actually going to start out with grade 9. But much of the content that is in grade 9 is actually similar to grade 8. So there'll be certain things that, for instance, I'll highlight it as I go through the video. As I go through the lesson, I'll highlight those aspects that are grade 9, that are grade 8. Yeah, so Nozipo, at 9 o'clock, I'll definitely be doing a grade 8 paper. I'll be doing some grade 8 content at 9 o'clock. All right, and that will be 9 up until 10:30. But from now, at 7:05 up until 9 o'clock, or 10 to 9, I'll be doing a grade 9 paper, a grade 9 maths paper 1 paper. Okay, so like I said, please share it out with any grade 9 learner or grade 9 students or grade 9 parent. You know, in this season, this time, a lot of them may be feeling very despondent, but like, we don't have to feel like that. Please open the paper. I don't understand when you say please open the paper. Oh, open as in like go. You want to see what's in the content of the paper. Wisani. Are you in grade 9? Please, if you're in grade 9, in the comment section, just write down grade 9 so that I know you are a grade 9 learner. That would be nice if I know you're a grade 9. And thank you guys for the follows. Yeah, the people that follow will definitely benefit a lot from future content, because I intend to do a lot of content that is not only grade 9, but like with future grades, you know. And I'll be doing live sessions. I'll make it a point to sort of post a sort of like information on my homepage with the times and the days that I'll be doing certain grades and certain papers, so that we can sort of like officialize this relationship. And then I would just ask that, please, if you are here, like yeah, so this is obviously time, and I mean, a lot of people would basically be, let's say, paying for a session where they would be having like grade 9 lessons or whatever taught. So all that I ask is you guys, if you can support the live goal, right? I have a live goal that I'll have for particular session. So supporting the live goal obviously will encourage me to continue to do these sessions and do these lessons, so that more people can have the opportunity of just having access freely on a TikTok page to actually have content coverage and all of that stuff. And then like precise explanation of certain, you know, aspects and concepts. Okay, so this live session will not only just be me answering questions, but I'm gonna try and also sort of like reveal to us what's the concept behind the questions that we'll be answering. Okay, so this is a paper, it's an Eastern Cape paper, as you can see, Nelson Mandela District, because that's the district I'm in. It was a maths paper 1 grade 9 term 4 examination. This is November 2023. So for any learner who's actually here in the Nelson Mandela District, November 2023 paper will be a good paper to go through, so that one can familiarize themselves with what was there initially, right? The time allocated is 1 hour 30 minutes and the marks are 75 marks. Now just some pointers here. When you are a learner in grade 8 and 9, grade 8 EMS, I am Fifi. Yeah, so I'm not going through EMS. So unfortunately, guys, this is South Africa, right? Yeah, South African paper. So I'll be going through grade 9. This is a grade 9 paper. So unfortunately, if you're in any other grade right now, someone who may benefit from also listening to what I'll be saying here in this paper would be a grade 8 learner, because much of the content that grade 8s and grade 9s do for maths are similar. All right, so hopefully that makes sense. All right, so this is primarily maths, guys. I'm gonna just have to clarify that this is maths. I am Fifi. For those who are wondering, when will I be doing a grade 8 session? I'll be doing it at 10 to 9 this morning. 10 to 9, I'll be doing a grade 8 paper. So those who are in grade 8 mathematics, you'll just need to hang on, or you need to rejoin the session at 10 to 9. So for now, I'll be covering a maths paper from 7 up until 10 to 9. And at 9 o'clock, I'll cross over and do a grade 8 maths paper. So we're just gonna have to hang in there, okay? Yeah, and this is exclusively maths. And I'm sorry just to say, guys, so this is just me doing maths. It will just only be maths, and it will be maths sort of like forever and ever. Hopefully, some of the people who are on this live, who are possibly teachers, and they are seeing that, oh, someone is saying grade 7 English, or someone is saying, oh, grade 8 EMS, and maybe they can also like start the initiative of actually pushing through with doing live sessions for these other subjects. But for me, this will be just maths. And yes, after I'm done with the paper plug, don't worry, I will post the paper, okay? And just something that I'd like to appeal to the audience, people who are coming in, please, you know, this would normally, you know, some people would pay money to have a session like this, and they would probably pay someone, and then that will be an hour and that will be done. So all I just ask is for people to support the live goal, all right, so that this can sort of like encourage me to continue with live sessions like this, so that people can be benefited. I mean, the more I see that there's support for this, then the more it will encourage me to continue to do it, okay? So just before I open the paper, I know you want me to get there, Lindy. So it's important to read the instructions. Whenever you are about to go into a paper, please, you need to read the instructions, okay? So the question paper consists of 6 questions, as you can see. Then it says answer all questions on the question paper. Please, people, this is important, because when you open the paper, you need to be able to see, you know, what is written here. If there are 6 questions, there are 6 questions. It means after you're done, you must have answered 6 questions. Answer all the questions on the question paper, which is very important. I mean, the only way you'll get all the marks is if you answer all the questions. All right, and then 3, show all calculations and steps clearly. Please, all steps that need to be shown, show them. Calculators may be used unless stated otherwise, okay? Then this one, 5, if necessary, round off to 2 decimal places unless stated otherwise. You must make sure that you round off to 2 decimal places as per instruction, unless in a specific question something else is said, okay? It's very important. Then 6, it is in your own interest to write legibly and to present neatly. Guys, your writing, please, let's make sure the writing is clear and clean. If you are writing the number 1, let it be clear it's number 1, not 7, you know. So please make sure that your writing is neat and can be read, you know, by someone. Okay, so let's jump into it. So for this paper, we had multiple choice questions, all right? And it would be nice that as I go through these questions, more than anything else, you make it a point that you answer. Let me just try and wipe. I think my lens is a bit foggy, so just bear with me a bit here. Okay, all right. I think that's a bit more clear. Okay, so the first question says, when 15 is divided, choose the correct answer from the 4 options. Write only the letter in the space provided. Okay, so what was nice is that this paper, they had the paper itself and learners could write in the spaces that were provided. So there was actually space there to write. So the first question says, when 15 is divided by 0, meaning 15 divided by 0, it is 1, A, rational, B, undefined, C, real, D, irrational. So hopefully, as we read through these things, we know that firstly, what is a rational number? A rational number is a number that can be written as a fraction where the numerator is an integer and the denominator is an integer, but the denominator cannot be 0. That is a rational number, right? So if we look at this, 15 divided by 0, even if, let's say, we were to write this as a fraction, right, it would actually be 15 over 0. This is not a rational number, right? Why? Because the denominator is 0. And we know that a rational number, yes, can be written as a fraction, but the numerator and the denominator, though they are integers, the denominator cannot be 0. So is it a rational number? No. B, undefined. What is an undefined number? An undefined number is any number divided by 0. All right. When we divide a number by 0, we say that the number is not defined. So when you say 15 divided by 0 and you put it in your calculator, you get this message that comes on, and it says maths error. That maths error means undefined. Okay. There are numbers that are defined. All right. Okay, we define those numbers, we know them. Some of them are rational numbers, some of them are integers, some of them are, and so forth. But 15 over 0 is undefined. Okay. C, real number. What is a real number? A real number, the family of real numbers are rational and irrational numbers. Okay. So is 15 over 0 a real number? No. D, irrational number. What is an irrational number? An irrational number is a number that cannot be written as a fraction, where the numerator and the denominator are integers and where the denominator cannot be 0. So that's very important. So our option that is correct, and I love that people have already answered. Uparara, the boy, said it's B. Okay. And Uwisani said it's B. And that's very true. So 15 divided by 0 is undefined. So that means our answer is what? Is B. Okay, are we together? Nice. B, 1.2, simplify. The square root of 9 over 16 x to the power 16. Now, I'm just gonna write this out here on the side, because when you answer a question, it becomes very important that you make it a point that you see what is supposed to be. So to simplify this, we're not just going to go and circle an appropriate option. We're going to do some rough work so that we can see what we are dealing with here. So first and foremost, inside the square root, 9 over 16 is a fraction, and then x over 16, right? So this is one term, all right? We call this one term, all right? Because it's a fraction times, and then obviously this here would mean the product of x to the power 16. So since this is one term, it means that the square root here can be applied respectively to the 9, to the 16, to the x to the power 16. So let's see this. So basically, when you apply the square root, it means we're going to have the square root of 9 over the square root of 16. And then that x to the power 16 as well, we apply the square root to these respectively. Does that make sense? Then what is the square root of 9? It's 3. What's the square root of 16? It's 4. And then x to the power 16. We need to remember that whenever we remove the square root here, we would actually say x to the power, and the exponential application would be x to the power 16 over 2. Right? So we divide the exponent by 2 because it's the square root of x to the power 16. But let's say, for instance, we had, let's say it was x to the power 16 and it was the cube root. When we remove that cube root, we'd say x to the power 16 over 3. All right. So what I'm saying is we are always constantly doing what? whenever we remove a root, depending on the type of root it is. So if it's a square root, obviously that means we take the 16, we divide by 2. If it was a cube root, we would remove the cube root by saying 16 divided by 3. Does that make sense? So that's very important. So our final answer here would be 3 over 4 x to the power 8. Makes sense? So that's what basically we are doing whenever we are applying a root. But we need to always check, all right? Because there is a law that informs what I've just done here, all right? You may have obviously learned this, that a over b, if you have the square root of a over b, you actually split the square root to the respective numerator and the denominator, then you apply it, and then you get the appropriate answer. Thank you so much, Maya, for the finger heart. Really appreciate it. So this is very important. A step at a time, we are able to actually get to the answer. So if we go back now to our options, right? We had 3 over 4 x to the power 8 as our first option. Second option, 3 over 4 x to the power 4. Third option, 9 over 16 x to the power 8. And then our fourth option, 9 over 16 x to the power 4. So if we go back to our step-by-step procedure and process when we were actually simplifying this, we applied the square root in the numerator, the denominator, and to the x to the power 16 because this is one term under the square root. You can apply the square root to one term under the square root, okay? And respectively, square root of 9 was 3, square root of 16 was 4, and then x to the power 16, because it's a square root, we divided the 16 by 2, and therefore we got 3 over 4 x to the power 8. So very correct, as you have said there, Yonela, Mam Jwacha Camille. It is A, that is the option we're supposed to choose. It is not B, though close it seems to be, because x to the power 4 makes it out. It is not C, because 9 over 16 is not what we obviously simplify the square root of 9 over 16 to be, and it's not. So let's move right along to the very next question. 1.3. The product of 2x to the power x minus 4 is, okay. Now obviously we have a monomial, which is 2x, and then inside this bracket we have something called a binomial, because there's two terms inside the bracket. So when we have a product, all right, of a monomial by a binomial, we apply a law called the distributive law. I repeat, whenever we have a monomial by a binomial, we apply a law called the distributive law. I love how people are just answering the question already or are giving me the letter. People are like, yeah, I can see people are prepared to write. Okay, and those who are joining in, this is like a Eastern Cape paper. It's not KwaZulu-Natal, guys, right? So because I'm in Eastern Cape, specifically the Nelson Mandela District. It's a Nelson Mandela District paper. And it was written last year by the kids in grade 9. So yes, I love what you guys have already alluded the answer to be. So let's just practically see. A monomial by a binomial, 2x into x minus 4. So I said we apply the distributive law. 2x we multiply by x, 2x we multiply by negative 4. And when we apply the distributive law, guys, okay, DL, meaning applying the distributive law, we use something that I referred to as an L. You may have seen these beautiful letters when you are watching a movie, you know, and this is a movie that's restrictive, you know, certain things will appear. But I want to suggest that in maths, S stands for sign, N stands for number, L stands for letter. So when you apply the distributive law, you first multiply the signs, multiply the numbers, and then multiply the letters. And when you multiply the letters, don't forget the exponential laws. Exponential laws. Now, this is what it means to write illegibly. You know, you can't see this very well. Okay, so do not ever write illegibly. You must be legible when you write. So exponential laws. Remember, a to the power m times a to the power n. When we multiply same bases, what do we do to the exponents? We add them. We must not forget these laws whenever we are dealing with letters, but it must be the same letter bases in order for us to add the exponents. If the base letters are not the same, then we simply combine the letters, when we're multiplying. And then division, and so forth, those laws. So let's go. So we distribute 2x into x, right? So the first thing we do is we multiply the signs s. So this 2 is positive. This x is also positive, all right, because it has a coefficient 1. We don't see that 1, but it's there. So positive times a positive gives us a positive. Okay, then we move on to the number. 2 times the 1. 2 times 1 is 2. Then we move on to the letters. X times x, these are same bases. So when we multiply the same bases, what do? We keep the base, then we add the exponents. So I'm going to write this out because people, we need to take note. There's a 1 there that's an exponent, and there's a 1 there that's an exponent. We don't see it, but it's there. It's just like all these other entities that are basically there, supposedly there. That's spiritual entities. They are there, but we do not see them. So we get 2x to the power 1 plus 1. Okay, so that would give us 2x squared. All right, so that's us distributing the first this monomial by the first term inside the bracket. If we take this, the monomial term and we distribute it to the second term in the bracket, we do the same thing. We apply S and L. A positive 2 times a negative 4. So positive times a negative is negative. 2 times 4, the number 2 times 4 is 8. Then the letter x, it's alone, so we just write the x next to the 8. All right, and then the final answer, we have 2x squared minus 8x. Make sense? So our letter option, you guys already got it, and I love this, is B. Please, people. All right, so the rough work on the side, ensures that we are able to choose the correct answer. Of course, some of us, I know we are so good. I mean, our mental maths is on point. So some of us don't even need to do the rough work on the side. And I commend those people that have that mental aptitude. It's beautiful. This is grade 9L, grade 9. Okay, then if we move on to 1.4, if a is equal to negative 2, then the value of minus 2a to the power 3 is. If a is equal to negative 2, you're a magician. I'm happy for you, Wanza. Minus 2a to the power 3. If a is equal to minus 2, what is the value of minus 2a to the power 3? I'm glad, Butala. I'm glad. And I hope that this really helps. So basically, we're going to take this expression, and in the place of a, we are going to substitute negative 2. This is very important. When you substitute this negative 2 into the expression, please use brackets when you substitute. In maths, brackets mean multiply. So we need to actually write this expression minus 2 brackets. In the place of a, we are going to substitute negative 2, right? Raised to the power 3. Then please take note of bad mass when you simplify. What does it mean, bad mass? It means you make sure that you start with the brackets, then you move on to the exponents, then you check out if there's any division, multiplication, addition, subtraction, in that order. All right, but thankfully this is just a single expression, and we are substituting into the single expression negative 2. So this negative 2 needs to first listen to the exponent. This negative 2 cannot want to have a relationship with this negative 2. We want to take this and multiply with negative 2 before. We need to first make sure that negative 2 to the power 3, we check what is negative 2 to the power 3. So this is an odd exponent, and according to bad mass, all right, please people, right, especially when we enter into grade 9. Now I know in grade A, in grade 7, in grade 6 and so forth, we did BOD mass, right, which was brackets of division, multiplication, addition and subtraction. In grade 9, because we do exponents even, at greater length, right, bad mass is what we need to acquaint ourselves with. In other words, brackets operation needs to be followed by the exponential operation. Okay, so please guys, all right, please, very, very importantly here, we need to start with brackets, then we, we check out the exponents. Hence, I'm saying in this particular question, minus 2 to the power 3, this exponent, is what we need to first apply. So brackets, then exponent. The multiplication of negative 2 with what is here will only happen later, but only after we've applied the exponent inside this bracket. So important. Hence, I'm saying, guys, I know it might be a new concept altogether. Some of you are like, hi, but I know board maths. What is this now? Brackets, exponents. Please, people. Please, please, please. Brackets, exponent. So if we apply the odd exponent, yes, it's for grade 9, David. If we apply the exponent 3 to the bracket negative 2, remember, this exponent 3 does not only affect the number, but it affects the sign of the number. Okay, and an odd exponent, if it's an odd number, people, and you have a negative sign, it means that the odd number will keep the sign negative. But if this was an even exponent, it would change the negative sign into a positive sign. I repeat, this odd exponent keeps the negative sign as it is. But if it was an even exponent, like 2, 4, 6, 8, if this was an even exponent, it would change this negative sign into a positive sign. So this is what we do. We retain the negative 2. Then 3, we apply the exponent 3 to the negative sign. So that becomes negative. And then 2 to the power 3. Remember, 2 to the power 3 does not mean 2 times 3. Please, people, if there's something that grade 8s and 9s repeat over and over again, remember, this thing, 2 to the power 3, means 2 times 2 times 2. If we're just applying the exponent 3 to the number, just forgetting about the sign. Remember, we said the odd exponent will keep the negative sign negative. So I've applied the odd exponent to the negative sign. It's negative, right? But please, people, 2 to the power 3 means 2 times 2 times 2, which means 2 times 2 is 4. 4 times 2, 8. Not 2, 4, 6. 2 times 2 times 2, 8. Not 2, 4, 6. Yeah. Let's please, people, let's not get this incorrect. I promise you that negative 8 is good. Then now, because the brackets, exponents are done, you move on. Division, is there division? No. Multiplication? Yes. Multiplication of what? Negative 2 and negative 8. What's negative 2 times negative 8? Because we have the bracket. Brackets mean multiply. So negative 2 times negative 8. I apply S and L. Negative times a negative, positive. 2 times 8, 16. So guys, if we go back to our option, is it 1.4a? Is it B? Is it C? Is it D? So of course our answer is A. Yes, Odirele. You're a champion. You are a champ. You're a champ. All of those people that goes down 16, you guys are champs. Like for days. And those who are also able to be sensitive to the fact that an odd exponent applied to a negative sign retains or helps retain the sign as negative. You guys are champs as well. Remember, people, if this exponent was even, you apply the even exponent to a negative sign, it changes the sign to positive. Okay, hope that makes too much sense. Okay, the delivery girl. What? You say you didn't know that part. Which part didn't you know? Okay, let's move on, guys. 1.5. Let's move very swiftly because grade 8 lesson will be in progress after this. Monique, thank you so much for the confetti. I really appreciate it, Monique. Much love to you. Thank you so much. Thank you. Then we move on to 1.5. The gradient m of the line y is equal to half x minus 6. The gradient m of the line y is equal to half x minus 6. Where are my maths genies here? The gradient. Okay. If the exponent is odd, it keeps the sign definitely utter. That's how it is, ne? Don't ever forget that. Don't ever. It's very important. But remember, utter, like I said, minus 2 to the power 3. It's because of the fact that this minus 2 is inside the bracket. The odd exponent is applied to the sign and to the number. You know something else? Sorry, just before I move on to the next question. something very interesting, guys. Actually, let's hold that one. Let's hold that thought. Let's hold that thought. All right. Let's move on to the next question. The gradient m of the line y is equal to half x minus 6. I love the answers. I see someone has given me an answer. It's just that I don't know the name here. Let's just see. Exists online only. Okay, I'm going to call you Exist. Ukatli. Okay, I love that. Ukatli says the gradient m of the line y is equal to half x minus 6 is half. All right. Okay, what does everybody else think on that thought? Odirile also says half. Okay, love it for you guys. Okay, it seems like we have a resounding you're new. Don't worry, I'm also new to this thing. Actually, I'm also new to to explaining a grade 9 maths lesson today to you guys. So we are all new. Pulu, so thank you so much. It is 1/2. Sweet stuff. So let's get some let's get some theory in here. Six, let's see. Siyamthanda, wouldn't 6 be the y-intercept? All right. I hear what you're saying, but let's hold our horses there. Siyamthanda minus 6. Gift and follow. Yes, Rubik. Rubik, definitely. We must do that. Supporting the live in that way will be really beautiful. Okay, anyway, so let's look at this, guys. So the gradient m of the line y is equal to half x minus 6. Guys, so here, when we talk about straight line or linear function, okay, we have in grade 9 we have linear functions or straight line functions. Okay, now your straight line functions have a standard or general form of y is equal to mx plus c. Some teachers may have used the coefficient m or the letter m and then c. I mean, it doesn't really matter what letter you use. The m stands for gradient. Okay, very important. The c here stands for y-intercept. Now, by y-intercept, that is where x is equal to 0. All right, on the Cartesian plane, on our Cartesian plane. All right, we have a y and an x-axis. So where x is equal to 0, in fact, where the graph cuts the y-axis, that is what we refer to as our y-intercept. So the value of c will give us the y value where the graph cuts the y-axis, which is very important. But on that y-axis, we know that it's where x is equal to what? 0. So that is c. M, on the other hand, is what we refer to as the gradient. All right, which is gradient can be positive, it can be negative, it can be equal to 0, it can be undefined. Okay, and I mean, for now, what's important here is that m stands for gradient, c stands for y-intercept. Take note that c together with its sign, so if this is positive c, then it means our y-intercept can be found above the x-axis on our Cartesian, above the x-axis. But if the c value is negative, the y-intercept can be found below the what? The x-axis. So this is grade 9, guys. Okay, it's grade 9, it's not grade 8. So if you are grade 8, all right, I'm having a session at 5 to 9. Okay, so for now I'm just going through grade 9. So m stands for gradient, but the gradient is only the gradient if the function or the straight line function is in this form. So if it's in another form, you need to actually tweak it and ensure that you have y is equal to mx plus c. Or some people say y is equal to a. The a still stands for gradient and the q still stands for the y-intercept. Okay, so do I do grade 10? Okay, I did do grade 10 earlier on in this week. My grade 10s, the grade 10 learners in the Eastern Cape wrote their paper yesterday, paper 1. All right. So yes. So this here, guys, M stands for gradient. So we are in this question that we are given y is equal to half x minus c. And then what are they asking? They are asking us for the gradient M. So what is the gradient M? Is it A, 6? No, definitely not. In actual fact, it's far from it, because first and foremost, we check, is this function in standard form? Yes, it is. Y is equal to half x minus 6. So this here, half, stands for my M, okay? Because firstly, the equation or the function itself is actually in standard form. So this half stands for the gradient. This minus 6 would be our y-intercept. So if we look at the options, is A, is the gradient of M A? No. Is it C? Okay, no. Something else that tends to happen here, guys, is that the function could have been maybe written like this. Okay, please take note here. All right. So many learners fall into the trap of thinking that the gradient is just 1. All right. Please take note here that this is written as x over 2, but the coefficient of x here is not just 1. So therefore, the gradient is not just 1, but it is the fraction in its entirety. It's 1 over 2. So had the function been written like this, we'd still have to take note that the gradient is 1 over 2. Please take note that this here and this here is the same thing, just that we have written it maybe in a way that may be confusing for many learners. But at the end of the day, what is the gradient of both of these functions? They are both respectively half. So our correct option here would be D. All right. So I know that many learners have already indicated that, and I love that. Chromacopia. I'm sure you could explain it. All right. It's just that I'm chasing time here, because I am actually in line to actually doing a grade 8 session at 5 to 9. So you'll just have to bear with me. In future lessons, I will see if I can't have sessions where people can actually come on and explain alternatively. So just bear with me today. This is my first time doing a grade 9 lesson on the platform in and of itself, and I'm still also learning, trying to navigate the space. So just bear with me, ne? PDD, it's definitely not baby oil. I think someone just commented there. I think some people are still caught up in that. Which grade is this? It's grade 9. It's an exam for term 4. Yes, a past paper for grade 9 that was written last year by the grade 9s in the Nelson Mandela district. Okay, question 2. So we're done with the multiple choice. It was 5 marks, 1 mark per question, and honestly, people, the content there, if you're a learner who has been preparing and is prepared well, and you've covered all bases with your content, all of these questions are just easy capizi. All right, so which numbers? Write the numbers. Sorry, question 2. Write the numbers in descending order. Now, what does this word descending mean? It means from big to small. Descend, coming down. You're coming from a high to a low place. That's what descending means. Ascend, if they had said ascend, we would move from small number to big number. But here we are asked to write the numbers in descending order. Now, very importantly, please, people, just know your numbers. You're not cooked at all, Kusone. I am trying to cook you guys so that you guys can be served, and dinner can be served when you guys write, so that you guys can just kill it when you write the paper. So write the numbers in descending order. Minus 203, minus 2,301. You're going to be cooking during the exam. Yes, definitely. Odiril, I'm happy with that. 166, 5. Thank you so much, Rubik. Minus 2 and 97. So we need to write these in descending order. What tends to confuse some learners here is that, you know, they tend to forget that the negative, okay, the negative, or what appears to be a negative number with a high value, right? So for instance, I think the familiarization of negative numbers, sometimes people tend to think that, yo, this is a very big number. For instance, minus 2,301. But in actual fact, this is the smallest number that exists in this sequence. So that's very important, right? So if we are going to write the numbers in descending order, we are going from high to low, right? So we are going to start with, okay, the highest number that exists here, minus 203, minus 2,301, 166, 5, minus 2, 97. The biggest number is 166. So we're going to start with that one. Then follow it with, yes, Kamogelo, we're going to follow it with this one. This takes second place. Then we are going to follow it with this one. This takes third place. Then we are going to follow it with this one. This takes fourth place. And then we are going to follow it with this one. This takes fifth place. And then last but not least, we're going to follow it with this one. This takes sixth place. All right. All right. I hope that makes sense, guys. So that when we write the order in descending, we are truly writing it from big, which means 166. We write our semicolon. We follow it with 97, which is beautiful. Then we follow it with 5. Then we follow it with negative 2. Then we follow it with negative 203. Then we follow it with negative 2,301. Please, guys, if we do that, then we can ensure that we are actually writing the numbers. And please, sometimes the meaning of a word can escape a learner's mind in the moment of answering it. Be sure that you've read the question. If it says descend, be sure in your head it means exactly that, from high to low. Do not make the mistake of having to write something, inappropriate. Okay. Do I have a math TikTok? Yes. My math TikTok, very small at the moment. Okay. You can go to Maths is a Game. All right. Maths is a Game. If you search for Maths is a Game, the content that is on there, it's fairly new, just recently posted, like my first few videos there. So Maths is a Game. I have some grade 11 and grade 8 content so far on that platform. All right. Also, I have a YouTube channel, but that's also still fairly new, and there's not much that has been posted there. I only posted me doing grade 8 papers there, and not famous yet. But if you can look it up, I'm sure you'll check it out. In fact, there on Maths is a Game, on the Maths platform, I actually have there on my Maths platform, Maths is a Game, there is an icon, my YouTube icon, that you can actually go to, and you can check out the videos that I've posted there where I've done answering grade 8 paper, specific grade 8 paper. But it's still fairly new. I'm still fairly new in the game, still trying to get the content up and rolling. So yes, I'll put the grade 9 Princess GGM and all the others as time goes by. Okay, let's go. Let's move on. So those are 2 marks, guys, 2 easy marks that you're supposed to get from 2.1. Let's move on to the next one. Calculate the following without a calculator. Now here, like I said, this is where we apply what we know. All right, you guys did perfect cubes, perfect squares, all right, and you did square roots. All right. Okay, so I repeat again, you guys did perfect cubed, perfect squares. All right, and by that I mean, if we look at some examples, you guys did this: 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And then I'm sure you guys also did this as well: 1 to the power 3, 2 to the power 3, 3 to the power 3, 4 to the power 3, 5 to the power 3, and so it goes, right? And you guys wrote down your perfect cubes 1 up until 10, and I'm sure you know mentally what your perfect cubes are. And then basically the other thing that was supposed to follow that was this mindset, or this mentality that, okay, if you know what the perfect squares are, then you should then know that the square root of these perfect squares will actually then give you, you have 1 here, you have 2 here, you have 3 here, you have 4 here, you have 5, and so it goes. The same thing with your cubes. All right, you guys were able to write these out. All right, okay, so these you're supposed to know mentally, and then the cube roots of these, okay, are things you're supposed to know mentally. You're supposed to know these mentally. Like, it's like me coming to you. If I come to you and I say, what's 2 times 1? You know that mentally. You're supposed to at least. 8 times 7. You're supposed to know that mentally. There's just things that we are supposed to know mentally. It's like our mental maths should be on point with these particular things. So for instance, okay, that's what we'd have. So the cube root of this, we know it's 1 here, it's 2 here, it's 3 here, it's 4 here, it's 5, and so it goes. All right, okay, and then the application of these, all right, in certain questions. So anyways, we are here now. Calculate the following without a calculator. So they don't want you to be using your calculator. So we have minus 12 to the power 2. All right, now this goes back to something I pointed out earlier on. Remember that when you apply an exponent that is even to a negative sign, what happens to the negative sign? If you apply an even exponent to a negative sign, what happens to the particular sign? This here will obviously become positive. Are we together? Then obviously, if you apply the same squared, thank you so much, Gatli, it's very true. If you apply the negative sign, if you apply the even exponent to a negative sign, it becomes positive. And then 12 squared, you should know, is equal to 144. And even if you didn't, I mean, you could take your calculator, right? And I know it says without a calculator. And what that means is that simply taking all of this and punching it into your calculator and then saying equal and writing the answer, that's not what they want here. They want to see your steps, all right? They want to see that you understand what minus 12 squared alone is, all right? And they want to see as well that the cube root of a negative 1,000, this odd root, if you apply that odd root to a negative number inside the root, it actually ensures that the sign stays negative. Are you with me? Such a different story if this this number here was not odd, but it was even. If it was the square root, we know that the square root of a negative number is non-real. Okay, it's non-real, all right, imaginary. But here we have an odd root, and when we apply that odd root to a negative sign, it retains the negativity. And then what is the cube root? Okay, the sign, we've applied the odd root to the sign. We apply the odd root 3 to the number 1,000. It gives us 10. Are you with me? And guys, this is the mindset that whenever you have an exponent applied to a negative sign, and remember this is in brackets, so it means that this even exponent must be applied to the sign and to the number. We apply it to the sign s, then we apply it to the number n respectively, so that we can see what we get. So it's a positive number, but it's positive 144 because 12 squared is 144. The odd root, we apply it to the sign, it retains a negative sign. We apply the odd root to the number, it becomes 10. Because we know our perfect cubes, guys. We know our perfect cube, and we know our perfect cubes. Whenever we apply the inverse of that, then we get the numerical value, right? So it's negative 10. Then 144. What is a positive times a negative? You see that because I have that bracket, positive times a negative gives me a negative. Okay, these are the steps that the person who's marking you wants to see. Then 144 minus 10 is 134. Someone had already given me the answer, all right, earlier on. But people, these are the steps. So if we go back to the instructions, like I said in the beginning, please, guys, show all calculations and steps clearly. The marks are there, guys. Please, please do not shortchange, the process and thus lose marks unnecessarily. I plead with you, I beg you. Okay. Something else to note here. I just want to see if let's say this had been what I would have been given. Okay, I just want to play here and just interrogate your mind. Minus 12 squared plus the cube root of minus 1,000. How is this minus 12 squared different from this minus 12 squared? This minus 12 is in brackets. The even exponent must be applied to the sign and to the number. Hence, when you apply the even exponent, this negative sign became positive. What about here? What about here? This exponent, all right, when applied to the 12, all right, this exponent is not applied to the negative sign. So this stays as negative 144 because there is no bracket. Thank you, Lwazi Shabalala. On point. Too much on point. So please, people, take note. Minus 12, the whole thing squared. In other words, a numerical term or a term inside the bracket with a even exponent, the effect, as opposed to a even exponent, no bracket, and how the even exponent only affects the number but not its sign. Very, very important. So in the same vein, this would lead us to negative 144 minus 10. And please, people, you know, some people, they butcher it exactly here. This addition of integers, you would rather please take your calculator, and Dylan, don't ever do what you've just done and write positive 154, because that's not the answer, Dylan. Please, guys, you would rather take the calculator when you get to this step. Oh, and please punch it in. There is no crime in doing that. Negative 144 minus 10, so that we can be accurate. Negative 154. All right. Please, guys. Please do. No problem, Dylan. No problem. You better make sure. Okay. Then let's go on to the next question. 2.2.2 minus. So we have 3 negative to the power negative 2 plus 3 to the power 0 plus 3 to the power 3. So let's go. 3 to the power negative 2. This can be written as 1 over 3 to the power 2. Aibo, how did... Remember, there's an exponential law in grade 9 that says a to the power negative 1 is equal to 1 over a. Do you remember that? I hope so. A to the power negative 2 can be written as 1 over a to the power 4. Okay. Which 114? What are you talking about? Wendy Mkoke. How did you get that 114, please? I don't understand. Which 114 are you talking about? Okay, maybe you can comment there. I won't move on until you help me understand which 114 are you talking about. I mean 144. Which 144? You mean this one? Or you mean that one? The first one or the second one, Wendy? This first one? Do you mean this 144? Tabo, you picked up on that error. I love that people are awake. I needed to see that. Okay, so we're in positive 144. Yes, it's an Eastern Cape provincial paper from last year, grade 9. So I said an even exponent. Whenever we have a bracket and there's an even exponent, the even exponent must be applied to the sign first. So an even exponent when applied to a negative sign, changes the sign to positive. That's the first thing. Then secondly, you apply the even exponent to the number without the sign. So if you apply the even exponent to the negative sign, that becomes positive. And then 12 squared is actually 144, which is a positive number. As opposed to this here, I said minus 12, the whole thing squared. There's no bracket here. So when you apply this even exponent, it only applies to the 12. Okay, are we together? The sign is still negative because there's no bracket around the entire number. Hope that makes sense. Now back to this. Yes, I love the fact that I love when people are awake, they are not sleeping. Tabo ora. I love that you actually picked that up. I said a to the power negative 2 is 1 over a to the power 4. All right, and that was a genuine error. Okay, it's supposed to be 1 over a to the power 2. Are we together? Yes. So in other words, what's happening here? All right, this in other words is just telling us the following. A negative exponent, a base raised to a negative exponent. Yes, Ren, I'll do grade 8. I'll be doing it at 5 to 9. 5 to 9, I'll be doing grade 8. So a to the power negative n. There's a 1 here that is a coefficient of the entire thing. So what happens is the following. The 1 stays in the numerator, which is the coefficient. And then the a to the power negative n moves from the numerator, okay, because this is like this, né? Initially. The a to the power negative n moves to the numerator, to the denominator, and changes its exponential sign from negative n to positive n. That is why, for instance, a to the power negative 1, okay, there was a 1. A leaves the numerator, goes to the denominator, occupies that position, and its negative exponent sign changes to bani, to positive. Are we together, guys? Here, a to the power negative 2, there was a coefficient 1 there. The a moves to the denominator. The exponent changes its negative sign to a positive sign. So that is why we can say that 3 to the power negative 2 is equal to what? 1 over 3 to the power 2. All right, I hope that makes sense. Okay, and then one more time. Let's just say, let's check this out. What if it was 2a to the power negative 1? All right, the exponent, that is the negative exponent, only affects the variable a. 2 is the coefficient. Is it affected by the negative exponent? No. So therefore, our answer will be that 2 stays in the numerator. A with its negative exponent goes down to the denominator. So our answer is 2 over a. What if it was 2a to the power negative 2, sir? Same thing. The 2 remains in the numerator. The a goes to the denominator with the exponent 2, positive, right? So I hope this application of the negative exponent makes sense, that the negative exponent will only affect the base that it is applied to. So for instance here, all right, 3 to the power negative 2, this is like 1 times 3 to the power negative 2. So what's happening here is that the 1 remains in the numerator. The 3 with its negative exponent goes to the denominator. Exponent changes from negative to positive. Are we together? All right. Then that's one of the things that we learn in grade 9 exponent. Okay. Then 3 to the power 0. A base raised to the power 0 is equal to, I need someone to tell me the in the bottom. Base raised to the power 0 is equal to, so it's not 0. Any base raised to the power 0, I love it. Lefa, KG, Love Girl, Katleho, you guys are phenomenal. You guys know your stuff. A base raised to the power 0 is 1. Any base raised to the power 0 except 0. Please, people. The only exception is 0. It's funny, yesterday the grade 12s were writing their paper 1. So I think the day before that, I went around to some of the grade 12s in my school, and I was asking them the question, what is 0 to the power 0? Okay. Guys, this is just exploring this, okay? 0 to the power 0, funny enough, is actually undefined. Okay, so I know some people tend to say any number raised to the power 0 is 0. The only exception there is when it's 0. Okay, 0 to the power 0 is actually undefined. Okay, so just something to note. But any other number under the sun, all right, if raised to the power 0, is actually equal to 1. But I want to explore this. So 3 to the power 0 is 1. 5 to the power 0 is 1. 8 to the power 0 is 1. But please note something here. What about minus 3 to the power 0? Minus 3 to the power 0 is equal to negative 1. This goes back to this thing of this exponent 0. What is it applying to? It applies to the 3. All right. Very different story from minus 3 to the power 0, the whole thing to the power 0. What is that? Okay, we have minus 3 to the power 0, which is equal to negative 1. The exponent 0 when applied to the 3. All right. The negative sign, the 0 exponent is not applied to the negative sign, so therefore the answer is negative 1. What's minus 3, the whole thing to the power 0? That means the 0 exponent is applied to the entire number. So therefore the answer is positive 1. Ish. Guys, I don't know. Like, kidding me or what? Guys, and these are the small things that if people don't get, they make mistakes because they fail to understand. So the exponent, in other words, what I'm saying to you and what I've been saying to you is that please do check where is the exponent applied. Which base is this exponent being applied to? In this case, the exponent is being applied to the 8, right? Which is already positive. So therefore the answer is positive 1. Right? Here, the exponent is applied to the 3, whose sign is negative. So the answer is negative because the exponent 0 is not applying to the negative sign, it's applying to the 3. So therefore the answer is negative 1. Here in this case, who is the exponent being applied to? Thank you, Asante. It's being applied to the entire number, negative 3. So if you apply the exponent to the entire number, negative 3, what does that yield? Because the exponent is being applied to minus and to the 3, that yields 1, positive 1. So this here, I don't know, like it's very important. Who is the exponent being applied to? It goes back to this thing, right? I know we're not talking about to the power 0 here, but it goes back to this concept of who is the exponent being applied to. So here, the exponent 2 is being applied to negative 12 in its entirety. All right. So when you apply this exponent, this even exponent, you must apply it to the sign first, s, and then you must apply this exponent 2 to 12, the n, the number. So therefore, when you apply the even exponent to the negative sign, it leads to positive. When you apply the even exponent to the 12, it leads to 144. As opposed to this here, who is the exponent being applied to? It's not being applied to the negative. So the negative stays negative, but the 2 exponent is being applied to the 12, hence 144, but it's negative. Do you see the difference between this and that, and the effect that a bracket will have if it's there or if it's not there? So don't mess around here. Okay, it's a big thing. Okay, sorry guys, I'm trying to emphasize certain points here because when those points are emphasized and you get it, and you apply it consistently to all problems, then you will always be winning. You will win. The maths will pop, the marks will pop, the level 7 will come, the marks will improve. But if you are careless about these things, these little things, yeah, then you're gonna say maths is a demon, you know. So 1 over 3 to the power 2, okay, remember, okay. Then 3 to the power 0, 1, plus, what's 3 to the power 3? That's like saying 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. Final answer, 1 over 9 plus 1 plus 27. Now I'm hoping that people here now have actually done addition and subtraction of fractions. All right, I mean, if we're wanting to make sure that we get step-by-step marks here, then here it becomes very important that we do that. So what's the lowest common denominator here? The lowest common denominator is 9. All right, so when we write our fractions, we want to write them in such a way that this lowest common denominator is reflected for all the fractions. So what do we do to the 9? To get 9, we times by 1. But what we do in the numerator, we do in the denominator. Now, you may have learned a different method, and that's fine. If you learned a different method from your teacher and you've consistently been applying that method, please stick to that method. Don't change your method. This is 1 over 1. But what do we do to the 9? 1 to get 9. We must times by 9. What we do in the denominator, we do in the numerator. Then lastly, this is 27 over 1. What do we do to the... Okay. So remember that we can't add fractions. At least we can't add fractions until the denominators are the same. All right. So that's 1 over 9 plus 9 over 9 plus, and I'm going to take my calculator and say 27 times 9, which gives me 243 for the numerator, 243 over 9. Then you can see the denominators are the same. So what permission does that allow me to now do? Now I can add the numerators. 1 plus 9 is 10, and then 10 plus 243 is 2. I love someone had already gotten the answer. There's like great people on this live. 243 over 9. All right, and you can leave your answer as an improper fraction. I know some people go ahead and they write the mixed number, okay, but you won't lose any marks if you write your answer as the improper fraction. Sometimes they may specify and say write your answer as a mixed number. Then of course you will go ahead and write your answer as a mixed number. All right, and how do you do that? You ask yourself, how many times does 243 goes into 9? How many times? 28 times, right? Yeah, it goes there 28 times, and that leads to 252. And then get 252, to get to 253 from 252 is 1 over 1 over 9. So it's 28 1 over 9. That would be our mixed number. Okay, so I hope that makes sense. All right. Okay, and people, that was 4 marks. Worth it? Very much worth it. Which part didn't you understand, Katlego? So I'm going to just repeat it one more time. So 3 to the power negative 2 is 1 over 3 to the power 2. Katlego, maybe you can just tell me in the comment section which part you didn't understand. We're getting to Cartesian plane very soon, honey boo. You're just going to have to hang tight. It's coming up. 3 to the power negative 2 is 1 over 3 to the power 2. 3 to the power 0 is 1. And then 3 to the power 3 is 27. Step 1. Step 2. 1 over 9 plus 1 plus 27. Step 3. This is addition, but it's addition of fractions as well. Now, I know maybe if you're a different person, you could have said 1 over 9 plus. And then that 27 plus 1, some of you would have said it's 28. I mean, that's okay. All right, because you're adding the numbers that you can see are whole numbers and you can add them. All right. Now, remember that when you are adding fractions, there's a rule that says we cannot add fractions unless the denominators are the same. Currently, the only denominator we have is 9. So we try and find something called the LCD. What is the LCD? The LCD is the lowest common denominator. Where does this concept of LCD come from? It comes from our understanding of lowest common multiple. But lowest common multiple for what now? We want to look at the denominator, right? 28 as a fraction. All right. Remember, any number can be written as, if it's a whole number, it can be written as that number over 1. Here, this side, we have 1 over 9 already. So 1 over 9 plus 28 over 1. So what we want to do now is we want to get the LCM between 1 and 9. But we don't say it's the LCM between 1 and 9 because these are numbers in the denominator. We say we want to find the lowest common denominator. It is the LCM between 1 and 9, but it's just that it's got this special name of lowest common denominator. All right. So the lowest common multiple of 1 and 9 is 9. Then we try and make it so that we can have this LCD reflected in both of these denominators. How? So what would we do to 9 to still get 9? We'd multiply by 1. But what we do in the denominator, we do in the numerator. What would we do to this 1 to get 9? We'd multiply it by 9. But what we do in the numerator, in the denominator, we do in the numerator. Then 1 times 1 is 1, 1 over 9, 28 times 9. So 28 times 9 gives me 252 over 9. Now the rule for fractions says when the denominators are the same, you can add the numerators. So there we go. 1 plus 252 is 253 over 9. And then, like I said, you can go ahead and write that as a mixed number. Okay. Where you ask yourself, how many times does 9 go into 253? And I mean, you can do that and say 253 divided by 9. All right. Then you get this. All right. And then basically you press SD. So this 28 is a representation of how many times 9 goes into 253. It goes into 253 28 times. But you want to check this 28 times 9. Up until how far does it get you? It gets you up until 252. It doesn't get you to 253. It gets you up until 252. How much more do you need to get to 253? You need 1 more. So that's why there's a numerator value of 1 over that same denominator, which is 9, if you were to write the answer as a mixed number. So this is an improper fraction, and this is a mixed number. So hopefully we know this conversion of mixed number and proper number. Hey Rory, you're killing me. This is how I got dyslexia. I'm very sorry. Are you are you still in high school? That is, I know some people have nightmares of maths, guys. I know that feeling. I know that feeling. All right, let's move right along, steady along, guys. That was for numbers. Let's go on to ratios, interest, and proportion. Okay, yeah, and try to be a bit more quick now. Write the following ratio in its simplest form. Okay, so we have 6,4. We have 4,8. You're kidding. Hi, you guys. These people that are on this platform, you're killing me, guys. 5,6. I'm currently doing this on my exams for business literacy. That's so cool, Elita. Oh wow, that's crazy. That is so crazy. Well, welcome to the live then. Welcome to the live. Hopefully you can support my live goal there, guys. Like, yeah, I love it. At the end of the day, this will spur me on. I just do want to say to those who are joining in for the first time, this is a first time me doing a live of this nature. This was directed to grade 9 students here in South Africa, but like I can see that it cuts across other modules, maybe in university level and all of that, because I know that in certain universities and institutions they tend to do this primary basic maths for other courses because it becomes important for those courses. So hopefully this is helpful, and I'm glad that you guys could join in and so forth, and I'm hoping this is good so far and that you guys are getting some value from it. Oh, it's part of ICB. That's crazy. Oh wow. Okay, neat. Where are you from, Alida? So thank you so much for the flowers. Really appreciate. The roses are sweet. So 6,4 is to 4,8 is to 5,6. Now some of you may be like, hey boo, ratios usually are expressed as whole numbers. What is happening now with the decimals? Okay. Yeah. I will, Mamshi. So 6,4 is to 4,8 is to 5,6. So what we want to do here is we want to ensure that we actually have these as whole numbers. Okay. Now I'm sure you guys can see all of these are 6,4, 4,8, 5,6. If we can get them to whole numbers, that would be epic. So what we're gonna do is we are going to times each number in the ratio by 10, because by doing that we get whole numbers. So if we times 6,4, we are moving the decimal to the right. This becomes 64. 4,8 becomes 48. 5,6 becomes 56. Why? Because I multiplied each numerical value in the ratio by 10. Because I can only simplify this ratio if I if I get these numbers, which are decimals, into whole numbers. So I need to first get these numbers, decimals, 6,4, 4,8, and 5,6, into whole numbers. So then I can then have the opportunity of being able to simplify them. So that becomes important. Okay, thank you so much, Alida, for the ice creams. Really appreciate it. You helped me achieve my sweet ice cream goal there. Thank you so much. So 6,4, 4,8, 5,6. We multiply each decimal by 10. 64, 48, 56. Then the next step is we need to find the HCF. Sometimes they call it the GCF, the highest common factor or the greatest common factor. It just solely depends on who is doing this, right? Okay. So remember, what was the purpose of timesing by 10? Oh, thank you so much for the confetti. Really appreciate it. What was the purpose of timesing by 10 initially? The reason for timesing by 10 was so that we could get the decimals to whole numbers. All right. Okay. Because simplification will only happen once we are able to get these decimals into whole numbers. After doing that, we then need to find the highest common factor for 64, 48, and 56. Now, does anyone know how we go about finding the highest common factor? Now, I know that for different, it just depends. If it's two decimal places, or two decimal places, all right, they would set it up in such a way. All right, let me just do this. 2 comma, let's say it was this. All right, yeah, because it will be consistently something you'd have to do for all. I mean, they won't give you a question whereby it won't you will consistently apply the same thing throughout. So if it was two decimal places, it means you're gonna have to move the comma twice in order to get a whole number. This is for all three numbers, right? Which means you would actually times by 100. Does that make sense? You're going to ask 3 decimal places times by 1,000, 4 decimal places. So I hope that makes sense. I hope you understand that you basically times by that 10 to the power depending on where the decimal is for the respective. But it would consistently be the same number. Hence, I'm saying that in grade 9, they will always give you a question whereby it will be consistently the same number that you'd have to multiply for each respective number in your ratio. Okay, so hopefully that makes sense, Odirile. So here we times by 10. Then our second step is to actually find the highest common factor for all three numbers, because that's the number we are going to divide by consistently for each of the three numbers. All right. So what's the highest common factor between 64, 48, and 56? Now, I don't know, like we've learned different approaches when it comes to the highest common factor for big numbers, for small numbers, and so forth. Now, I know that maybe some of us, we did this approach where we would write the factors of the numbers, and then after that, we'd identify the highest common factor. Some of us learned, is it the ladder method? The ladder method, where you write 64, you write 48, okay, you write 56, and then you get the product, the numbers as product of their prime factors, and then you are able to then identify the highest common factor. All right. This question is 3 marks, so it would be nice if we could just find the highest common factor as easily as possible. Okay. So the highest common factor between 64, 48 and 56. Anyone? Is there any easier way of doing it on your calculator? People want to do. Yeah, remember people, it goes back to this thing. I did say earlier on that is steps, they need to see the steps, right? So the highest common factor here is 8, all right? Yeah, so then what we do, we divide each number by 8. And when we do that, divide each number by 8. What's 64 divided by 8 is 8. What's 48 divided by 8? It's 6. And then last but not least, what is 56 divided by 8? It's 7. So you have 8 is to 6 is to 7. And this here cannot be simplified any further. So here, that question was 3 marks. And this is simply the marks. You being able to multiply by 10, getting the HCF and dividing each number in your ratio by that highest common factor, and then your answer. 3 marks in the bag. All right. Yeah. So in grade 8, you guys learned how to find the highest common factor. So it should then follow naturally that you are able to find the highest common factor for these numbers, and then you divide each number by the highest common factor, which then leads to the beautiful answer. Okay. Like this is not going as fast as I would wanted it to. Okay, next question. Naleti and Emily invest in a business in the ratio 1:3:5. If the profit is 450,000, how much does Emily get? So we have 3 people here. You have Anna, Leti, and Emily. They're investing in a business. I think this would probably have so much more great appeal for my good friend Elida here, who sent me the confetti. Thank you so much, Elida, for all the confettis. 1, 2, 3, 4. Thank you so much. Like, I really appreciate that. Okay, I love this. I love how people are just like busting out like some answers there. Okay, so step number 1 is who's this? I love it. Okay, it's just that I can't see your name. HSJK HSFU. We first add the ratios. Very true. Okay, so step number 1 for a question like this. But firstly, we know Anna, Leti, and Emily. These are 3 people investing in a business in the ratio 1:3:5. I'm guessing, Elida, you're going to be definitely probably doing that in the future, right? So if the profit is 450,000, how much does Emily get? Emily, all right, is the one that's taking a 5 stake in the business. Leti is taking a 3 stake, and then Anna is taking 1 stake in the business. Okay, so the ratio is 1:3:5. The 1 is representing Anna, the 3 is representing Leti, and then the 5 is representing Emily in the business. And then if the profit that they make is 450,000. Guys, please don't write 45,000. Make sure you write the number as you see it in your question paper. Sometimes we make mistakes because of that. So I love what someone said. We need to first add the ratio. So we add the ratio. Okay, so it's like 1 part plus 3 parts plus 5 parts is equal to, in total, we have 9 parts, right? Okay, then after that, the part that we are interested in, because that is the part that we are being asked, is actually Emily's part. And Emily's part is represented by the 5 parts. So we're going to take that 5 parts of Emily. We are going to divide it by the total number of parts, which is the 9. And then we are going to multiply that by the profit, which is 450,000. This is Emily. How much does Emily get? All right. So I took Emily's 5 parts, divided it by the total number of parts, which is 9, and then multiplied it by the profit, which is very important. Okay. So here, this question was very specific. All right. They said, how much does Emily get? Some people would probably go the length of saying 1/9, calculate Anna's part, calculate Letty's part, calculate Emily's part. please people, whenever the question is specific and direct, answer the question, right? Don't try and answer the questions that were not asked. Remember, you are time pressed. The question is 3 marks. You only have this limited amount of time to utilize to answer the question. So you need to make sure you become as direct as possible. Had they asked how much does Anna, Letty, and Emily get, then definitely you would go ahead and you would calculate the profit for all 3 individuals. But because you are being asked to how much does Emily get, please, let's stick to it. So 5 over 9 times 450,000, we go ahead and I love this calculator. This calculator, scientific, you just put the 5, say 5 over 9, then you do what? 5 over 9 you calculate, then you times it by, and make sure you punch in things right, guys. Some people, they fail here. They punch things wrong. Make sure the zeros are the amount of zeros that you need. Just imagine if you forget 1 0, you say equal, you write the answer, you move on, you're like, yes, I got it. But then later on you find that, boo, you messed up. So yes, the answer, as even shared by someone earlier on, I think it was, let me just see, Siyabonga Hlengwa. Thank you so much, sir. 25,000 phakathi inside. Emily gets that much, so therefore Emily gets, please people, I'm sorry for my writing, it is not illegible. It is not the writing that you want to be having when you are writing your exam. Okay, you want to have Schwab's writing, 3 marks. Okay, so it's very important. First add the parts, all right, get the total number of parts, then you take Emily's stake of 5 parts, you divide it by 9, the total number of parts, you times it by 450,000. All right. No, guys, I did forget the 0. Okay, so this is exactly what you want to avoid. I did. Remember what I was saying earlier on? I was saying that please, whenever you are, so do you see where the error came about? The error came about simply because I did what? I did not put the amount as I had actually seen it on my paper. All right, and I'm not pleased with myself for having made that error, but I'm glad I did, because it needs to be a learning curve for all of us, that you need to make sure that you put the required amount there. All right, and then when you press, you see the calculator will serve you what you give it. So yes, the calculator did serve me what I gave it, right? So that's why initially my answer was wrong. So yes, it's 250,000. I mean, Emily is getting pretty much the biggest stake from the entire business situation here. I mean, 5 parts is quite a lot, eh? No, that's fine. I'm glad. I'm glad. I'm not in any way someone that claims perfection. I'm not perfect at all. Like, I do definitely mess up. But I'm hoping that obviously the lesson is learned. The fact that Nyanike, as you said, is kuzila about forgetting the 0, then I proceeded to doing it. Funny, hey, for days. Okay. Emily must share the money. What did you mean? Well. Okay, 3.3, let's go. Jan borrowed 10,000 Rand from the bank at 9.5% compound interest per annum for 3 years. How much money must Jan pay back after 3 years? Okay, right, so this is a typical loan. Okay, typical loan question. Jan borrowed 10,000 Rand from the bank at 9.5% per annum compound interest per annum for years. How much money must Jan pay back after 3 years? All right. Now this is very sweet and awesome. After 3 years. So very quickly, just for the benefit of the masses. So there's a formula that relates to something that we refer to as simple interest. All right. And then there's something else that we refer to as compound interest. Okay. So in compound interest, there's this beautiful formula. Whenever we are dealing with interest that is compounded annually, and we want to find out what effect does an investment have All right, if we invest a certain amount of money and then we want to see after a certain number of years how much money will you have, but it's at compound interest, then we would use this formula. All right, I mean, this also applies for a loan. Okay, so this is the formula. A is equal to P for compound interest. A is equal to P, right, brackets 1 plus I to the power n. A is what we refer to as the future value. It's the future value, okanye the accumulated amount. It's like the amount that one can expect to have or make after a certain number of years, after time has passed. It's like a future value, the amount made after years. P is called the principal amount. So if you are investing, it's the invested amount, but if you are taking out a loan, it is the borrowed amount. So principal amount, okay. Then I okay, sure, no problem, tax. I is equal to so I is the interest rate, and please, it's the interest rate as a decimal. That's what I is. It's the interest rate as a decimal, and then n is the number of years. Okay, so what are we told? Jan borrowed 10,000 rand. So that 10,000 rand that he borrowed is what we refer to as the principal amount. Okay, the borrowed amount. Okay, principal amount, I said the principal amount is the invested amount if we are talking about investment, or borrowed amount if we are talking about a loan. So if it's a loan, it's the borrowed amount. Okay, that's the principal amount. Okay, so P is equal to like I said, P is equal to 10,000 rand in this case. Then N, the number of years, is 3 years. Then I is equal to the interest rate. In this case, interest rate is 9.5, but since I said I is the interest rate expressed as a decimal, we take this 9.5, we divide it by 100. Okay, and 9.5, if we divide it by 100, gives us 0.095. And then last but not least, A, that's what we are actually looking for. Okay, so just to repeat again, it says Jan borrowed 10,000 rand from the bank at 9.5% per annum compound interest per annum for 3 years. So Jan borrowed 10,000 rand. So this is the borrowed amount. So like I said, the principal amount can either be the invested amount if we are talking about an investment, but then if it's a loan, then we talk about it being the borrowed amount. I, the interest rate, but I is the interest rate as a decimal number, all right, not a percentage. So the interest rate as a decimal number, all right, 9.5 obviously is 9.5%. We take that 9.5%, we divide it by 100 so that we can express the interest rate as a decimal number. Then A, how much money must Jan pay back after 3 years? Okay, all right, so basically here it's very important that we note they are asking at how much money must Jan pay back after 3 years. So this is the A that we are talking about. Okay, the amount of money Jan must pay back after 3 years. So we're gonna check out what is this amount that Jan must pay back after 3 years. So first and foremost, we are going to write our formula, then substitute into the formula. So 10,000 rand, 1 plus I. The I is already in decimal form as a decimal number, and then it's to the power what? To the power n to the power 3. So all you do is you take your calculator, you punch that in. So that's 10,000 to the power 1 plus 0.0095 to the power 3. Sorry, to the power 3. Pakati inside, A is equal to 10,287. Now they said in the instructions in the front that we must round off the answers to 2 decimal places. Take note, 7-1. This is the cutoff. 7-1 is the cutoff. But we look at the number, the third number, which is 6. 6 says what to the 1? If this number is a number that is 5 and above, then this number will go up by 1. But if this number, say this number here was a number less than 5, meaning it's 4, 3, 2, 1, then this number 1 would stay the same. But what's going to happen now to this 1, since we are rounding off to 2 decimal places, it will go up by 1. So our answer is 10,287 Rand, 72 cents. 72 cents. Make sense? Ne? Right? And I just want to go back again. This question is saying how much money must Jan pay back after 3 years? Okay. Okay. This is the amount of money that Jan must pay back after 3 years. So let's practicalize this thing. If I am going to go to a bank and I'm going to go and study, let's say I've finished my grade 12. Unfortunately, my marks were not great. Therefore, I missed out on the opportunity of getting the marks that would afford me the opportunity of getting a bursary. Then what ends up happening? I go maybe to EduLoan. I go and borrow amount of money. I don't have registration money. I borrow 10,000 Rand. And then the agreement is that the agreement is that as I borrow this 10,000 Rand, the interest rate is 9.5% and it's compounded. Is it? It was, you're right. Why? Okay, guys, so once again, do you see what's happening here? I'm sorry, guys, I'm very sorry. Okay, I'm making errors here. Not, comma, not. Do you see what I did? Not, comma, not. Okay, so I added a 0. Okay, guys, don't do as I do. Do as I say. All right, like don't do as I did. Thank you so much for bringing that up. You're amazing. Who's this learner there? Your calculation was wrong. That girl, Kanya. Wow, thank you so much. Good on you. You're just a girl. You God-fearing. No, definitely there. I could see. Thank you so much. I really appreciate. Not, comma, not 95. So let's just do that again. Sorry, guys. That was me making another error. So the answer is 13,129 Rand. Okay, sorry, let me just redo that again. Sorry. So that's 13,129,32. Okay, so guess maybe something that we were just supposed to learn from that error of mine was just this rounding off. So 13,129 Rand, 32. 2 decimal places. The third number is a number that is less than 5. It's 4, 3, 2, 1. So it's 3, right? So therefore, what does it say to this number? You stay the same. So that's why our answer is 13,129 Rand, 32 cents. Okay. What I had done, the error I had made is that when I punched into my calculator, I put another 0. Okay. So please, guys, both of the errors that I made had to do with me not putting the answer that I had gotten and punching in the wrong value and somehow adding a 0, putting a 0 that I'm not supposed to put in there. And these are so common. The error that I made is so common. Sometimes even when I'm marking learners and they've submitted stuff, like, yeah, it's one of those errors that can be quite frustrating. So let's not make them. Let's learn from what errors I've made so that we don't repeat them. So hopefully that makes sense. So going back to my loan example, if you make that loan, guys, remember that you are going to take most of that 10,000, you're going to utilize it, you're going to register at university. But remember that when the 3-year period, is done, basically the bank will be waiting for you to actually pay back this amount of money. All right. You borrowed this amount of money, but after 3 years, you end up having to actually pay back this amount of money. So that's the amount of money that Jan is going to pay back after the 3-year period, because that was the agreement that he entered into when he took out that loan. All right. So let's really study hard and work hard so that our marks can actually warrant us getting a bursary. What's nice is that when you get a bursary in South Africa, you don't have to pay back money. That's not a loan. So we need to work very hard. So calculate. Then the next question is calculate the interest after 3 years. Okay, the interest. All right. So in other words, how much? Yeah, what is the interest? Okay, after 3 years. Okay, so the interest after 3 years is when we take the A and we subtract the P from it. Okay, the interest. Okay, it's when you take the A, you subtract the P. So the A amount is that 1312.9,32. Then we subtract the 10,000. Okay. Yeah, because what's happening here is that you're not paying back. You took 10,000, you're not paying back 10,000. There's an extra amount that you are paying because of the interest rate, 9.5%. Okay, so that is what they are saying here. Calculate the interest after 3 years. So we take the accumulated amount, or the amount after the number of years, and we subtract it from the amount of the loan. So if we do that, 131,29,32 minus 10,000, that gives us a beautiful, then we press SD so that we get the decimal. That gives us 3,129.32. So it's 3,129 rand 32 cents. That is the interest. Okay. All right. Okay, let's move right along. It seems like the session for the grade 8 will be delayed a bit here because things are going at a very slow pace. Okay, let's move right along. Next question. The following table shows the time it takes for a train to travel a distance of 300 kilometers at different speeds. Okay, let's study the table. The speed in kilometers per hour, we have 30, 40, 60, y. Then time in hours, we have 10, 7.5, x, and 3. If you look at the numbers at the top, 30, 40, 60, y, these are numbers that are increasing. Time, on the other hand, 10, 7.5, it seems like these numbers are decreasing. So let's be very clear. These are increasing. In other words, this is increasing quantities, whereas time is a decreasing quantity. So that's very important to know. Just something to note in your head. Then it says, do this data form direct or inverse proportionality? Okay, guys, you guys did direct and indirect proportion. In other words, direct proportion, okay, where direct proportion says that as one quantity increases, then the other quantity also increases. Or it can be as one quantity decreases, the other quantity as well will decrease. So direct proportion has everything to do with if one quantity is increasing, the other one is also increasing. Or it can be as one quantity decreases, the other one also decreases. So it's increase, decrease. That's direct. Indirect or inverse, because that's the wording, indirect or inverse proportion. As one quantity increases, the other one decreases, or vice versa. As one decreases, the other one increases. So let's look at this. Speed is one quantity. What's happening to speed? 30, 40, 60. It seems like it's increasing. What's happening with time? Time, as speed increases, time is doing what? It's decreasing. So what type of proportion then is this that we are seeing? Lefa maluleke, spot on. All right. Okay, here they used this word. Do this data form a direct or inverse proportionality? So let's just use the wording that they have provided for our option. I hope that makes sense. You wouldn't be wrong, obviously, if you said indirect proportion, but it's just that let's be specific to what they've asked, you see, so that we, even the examiners or whoever is marking, can kind of like see, but oh, okay, we understand that indirect is also inverse proportion. Then 3.4.2 says determine the values of x and y. Now, people, at this point, this is very important to note that because this proportion is indirect or inverse, all right, as one quantity increases, the other one decreases. So what we do is that the relationship formed here, okay, they say determine the values of x and y. These exist, 30 and 10, my speed and my time exist. They are there, all right? Then here, okay, my speed and my time also exist. Here, my speed exists, but my time is not there. So I can use this and this together to be able to find my value of x. Okay, and then I can also use this and this to find my value of y, which is very important. So we have speed and time here, which is very, very important. Now I know the minute people hear speed and time, they think of this, all right? And I'm sure when you think of this, you think of distance being speed times time, right? Because that is the relationship that exists between speed and time. The product of speed and time gives us distance. That's the relationship. So what we do here then is we are going to take 30 and 10 and write it as a product. 30 times 10. And then we're going to take the 60 and x and also write it as a product. And I mean, this is simply what we can do. 30 times 10 and 60 times x. We know that these are equal. All right. So 30 times 10 is 300 and 60 times x is 60x. Are you with me? All right. All right. But this has to do with the fact that whenever whenever the relationship between these quantities is inverse or indirect, then we can express these as products of each other and then equate them. If it was direct proportion, we would express these not as products, but we would actually write them as ratios. It would be 30 over 10 is equal to 60 over x. Or it would be 10 over 30 is equal to x over 60 if it was direct. But since it's indirect, we write them as products and we equate. So this is what I'm going to do. 30 times 10 is equal to 60 times x. And then I'm going to solve this. So let's solve it. That means we have 60x is equal to 300. We divide both sides by 60, the coefficient. Okay. And then we get x is equal to, what's 30 divided by 60? 30 divided by 60 gives me 5. All right. So obviously, I would write there 5 hours. Okay. I would write there 5 hours, which is very, very important. I would write 5 hours there. That's what I would do. So in the place of x, I would write 5. Okay. Then I want y as well. All right. So I mean, I could go ahead. All right. I can use this 30 and 10 and use this y and 3 and do the same thing. So 30 times 10 is equal to y times 3. Same thing. Okay. 30 times 10, that's 300. Y times 3, that's 3y. And then what do? I divide both sides by the coefficient of y, which is 3, which gives me y is equal to, what's 300 times 3? It's 100. Y is my, okay, yeah. All right, so yeah, that's it. That's that. Okay. my x and my y. Okay, let's move right along very swiftly. I think here there's still a bit more. I think. Alina, yes. Do I do grade 11? Yes. I will be doing grade 11, but just not today and probably not tomorrow. I think in the beginning of this new week, maybe, just maybe, if I'm prodded or pushed, I might do grade 11 tomorrow. Yeah, I might do grade 11 tomorrow. Reshow the calculation of y. So people remember, ne? I said inverse proportion or indirect we look at the product or multiplication and we equate. But if it was direct, we wouldn't look at the product. If it was direct proportion, we would look at the division. Okay, please people. All right, if it was direct proportion, we wouldn't say 30 times 10 is equal to 60 times x. If it was direct proportion, we would say 30 over 10. We would actually set it up as fractions, which is very important. So it's a different story. Inverse proportion and indirect proportion leads us to set up these as products. Okay, yeah. I will actually be posting Latine. I'll be posting the pictures. This is grade 9, by the way. It's not grade 8. I will be posting the pictures of the questions after I'm done with the live. Okay, so don't worry if you're stressed about that. Don't worry. Okay, so just going back there again. So we said this is indirect proportion. So what I did is, for finding the value of x, we said 30 times 10 is equal to 60 times x. Okay, 30 times 10 is equal to 60 times x. Why? Because the relationship is indirect proportion on inverse, which means we formulate our equation using the product of the respective quantities. So 30 times 10 is equal to 60 times x, in that order. 30 times 10 is equal to 60 times x. What's 30 times 10? It's 300. What's 60 times x? Is 60x. Then obviously what I said then is that 60x is equal to 300. I mean, that's the same thing. You divide both sides by 60, you get x is equal to 5 hours. How did we get the value of y? So same thing, we went back to our table. We took 30 times 10, we equated it to y times 3. And then what's that? 30 times 10 is equal to y times 3. 30 times 10 is 300. Y times 3 is 3y. Then we divided both sides by 3. We got y is equal to 100 kilometers per hour. Because remember, y is actually our speed quantity, whereas x was our time quantity. Okay. Okay, so let's go. I need to move on. So this is grade 9, people. So those who are joining in, this is not grade 8, but there are some things that are similar to grade 8. So for instance, these number patterns I'm going to be doing now are a grade 8, also relevant for grade 8. So here we are told, write down the next two terms in the pattern: 15, 22, 29. You tell me, what's the next two terms, guys? What do you see here? What type of sequence is this? 15, 22, 29. 15, 22, 29, these are what type of linear pattern? I mean, what? Oh, there we go. I think I just told you guys. So this is a linear pattern. It has a constant difference of 7. Yes, we add 7. Definitely true, Utimna. So plus 7 gives us 22, plus 7 gives us 29. Then we need the next two terms, which means we need to add another 7. What's 29 plus 7? So very true, Reggie, you are right. Followed by 36. They want just the next two. Then after that, we add 7. Reggie, you are right. It's 43. 4.1.2. Okay, 4.1.2. Okay, guys, I'm going to have to push it. I'm sorry for the grade 8s here. I'm going to have to push this live lesson up until 9:30 because there's still a bit I need to do here. So please do bear with me. 9:30. Still a little bit more I need to do for this Landoga. So I'll push it up until 9:30 for grade 9s. I didn't expect that it would take this long, but it is because, I mean, there's quite some meat here meaty stuff, and I definitely not going to just sabotage and not explain certain things. Okay, describe a rule to describe the general term Tn. Yeah. Okay, so I think let's do this. Grade 8. Okay. Where will I post the question paper? I will be posting it in this page, in this particular page. And then I'll also post it in my Maths is a Game page as well. So I'll post it both. Okay. Now listen to me very quickly to the people that are joining in here and they are in grade 8. Grade 8, I will only do you later on today. So let's say 1 p.m. All right, so that I can actually give sufficient time so I can run through this grade 9 paper and actually finish it. Okay, I'm wanting to at least do this up until 10:30. Let's say 10:30. Okay, 10:30. Do I have GC for grade 9? Yes, there is GSA for grade 9, but I don't have it now here with me. Okay, because I know GEC is a lot of what you might call. You guys do a lot of multiple choice, but even those multiple choice, yeah, are very important. Number 10, if you want to do one-on-one, just DM me, send me a message privately. Then we'll take it from there. Just send me a message, TikTok message privately, and then we can see how we can arrange that and sort of like what does that entail and so forth. Okay, I do know that when I do a session like this, it doesn't appeal to everyone. Yeah, when will I do paper 2 grade 9? Definitely next week. But like I said, I'll be from next week onwards, or at least towards the end of this week, maybe on Sunday. What I will do is I'll actually I'll send a poster as to when I'll be doing what grade, what time, and all of those things, and then I'll make it available generally for everyone. Okay, yeah. Will I be able to do GSC for grade 9? I don't think so today. All right, I don't think so today, but just maybe at another time. Okay, so just bear with me. I will have a lot of DMs. That's fine. I'll get through them. Don't worry. Send those DMs. I'll get through them. It's one of those things. Man. Don't worry. Determine a rule to describe the general term. I will post the question paper. Don't worry. I'll post it on my page. Don't worry. It will be done. So determine a rule to describe. Thank you so much, Moss, for the hot me. Determine a rule to describe the general term Tn. So since this is a sequence that has a constant difference, we know D is equal to T2 minus T1. We always want to confirm the authenticity of this constant difference by also checking if T3 minus T2 it holds up. Don't ever assume that a sequence has a constant difference simply because you took T2 and you minus T1. You must check if consistently that constant difference applies for all terms. So T2 minus T1 does give us 7, and T3 minus T2 does give us 7. So Tn is equal to Dn plus C. This D represents the constant difference, right? There represents the constant difference. So Tn is equal to, the D there represents the constant difference. So it's 7n plus C, but we don't have the C value. Now, depending on how you've been taught this, I know that some people use other formulas, but I won't go into those. And there's a reason why I won't go into those, like your Tn is equal to A plus N minus 1, the whole thing D. The reason I don't utilize that formula is that it has direct sort of like application for your grade 12 content, right? So for now, for our linear pattern in grade 9, Tn is equal to Dn plus C, especially for my learners this side of the world. Tn is equal to Dn plus C. The D, the coefficient of N, just means constant difference. C, all right, is simply the difference between T1 and D, all right? But, yeah, we can use that simultaneously. If we have Tn is equal to Dn plus C, and we were able to find that the constant difference, 22 minus 15 is equal to 7, then we know that we have Tn is equal to 7n plus c. We want to calculate the value of c. You have terms 15, 22, 29. 15, 22, 29. 15 occupies the first position. 22 occupies the second position. 29 occupies the third position. You can take any term with its position and find c. So I like that. So take any term. So let's say we take term 3. That means in the place of Tn, we substitute 29. In the place of n, 29 occupies which position? It occupies position 3. N is 3 plus c. Then you can solve for what? For c. You transpose. Therefore, c is equal to 29 minus 21. 29 minus 21 is equal to 8. So therefore, when you write the formula, it's Tn is equal to 7n plus 8. Does that make sense? So you can always take a particular term with its position. I mean, you could have taken, guys, I just want to show you that this works for everyone. T7 into. So if I took the term, this one, the second term, 22, right? I can take 22, substitute its position, all right, the position 2, plus c, all right, and then I still get c is equal to 8. Does that make sense? You take the 14, you transpose it, 22 minus 14 gives you 8. So therefore c is equal to 8. Okay, Boiti, I just want to capture you there. Where are you lost? Sissy, where are you lost specifically? All right, this is grade 9 real sigma. Oh, you thought it was grade 8, but this is grade 8 content. So real sigma, the thing is, I've had to move that class, that grade 8 session, because the grade 9 session I've had to explain certain things, so it's taking a bit longer than I thought. So let's do it like this. Let's then just agree I will only be able to do a grade 8 session at 1 p.m. today. So bear with me. So this is grade 9, okay? Grade 8 I will do at 1 p.m. today, okay? But this content that I'm doing now applies to both grade 8 and grade 9. I hope you understand that. Yeah, okay. So this applies to grade 8 as well. Okay. There's a few things that we do in grade 9 that are not done at grade 8 at all, right? So that's why I'm saying that please do come back when I do have the grade 8 session, which will be at 1 p.m. today. 1 p.m. All right, 1 p.m. I'll do a grade 8 session. Okay, 1 p.m. 1 p.m. Now I'm still busy with the grade 9, so just bear with me there. Okay, now I'm doing grade 9. I'll do a grade 8 session at 1 p.m. I'm so sorry, guys. I'll do grade 8 at 1 p.m. Ne? 1 p.m. So Boiti, I don't know if Boiti is still, because Boiti did say she's lost the okay. Yes. So yes, but this is also grade 8. I mean, this particular content here is also done in grade what? In grade 8. So that means Tn here will be equal to 7n plus 8 then. Okay. Paper 2. I'll only do paper 2 tomorrow. But I will be posting up a poster, guys, okay? I'll be posting up a poster that I will have on my page so that I can let you know when certain sessions I'll be doing them, so that people can then join during those times. So let's look at the next question. 4.2, study the following geometric pattern. Okay, one figure has one square, second figure And then last but not least, the third figure. Yeah, so I'll do grade 10. So my grade 10s, paper 1, they wrote yesterday. So I'd been doing grade 10 this week, all right? So if you want me to do grade 10, I'd need to know which province are you in, when are you writing your paper 1, and when are you writing your paper 2, so that I can actually then tweak my time and my availability to accommodate maybe get grade 10s for a specific session at a specific time. Okay. Yeah. Grade 12, no, grade 12, I'm off from grade 12. Okay, guys, this is just maths, not maths late, so it's just pure maths, guys. I'm sorry, pure maths. And grade 12, no, I'm not touching grade 12. It's too sensitive, grade 12, very, very sensitive. So I'd rather allow your teachers to sort of like do the last final touches with you guys the way that they see fit. So hopefully you understand that. Okay, figure 4. We need to draw figure 4. Do you see this figure 1? You see figure 2. There's 3. So it's 1, that 1. But there's 3 now. And here, there's that 1, which was there. There's that 3, which is there. We've added another layer, which has 4. So the next figure, how will it look like? Okay, so it will definitely have the 1, no doubt. Then it will have, right? Okay. Yeah, my drawings are pretty romantic, aren't they? Then it will have, of course, because 1, 3. Then it will have, and then it will have. So that 1, 2, 3, 4 is there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's there. But then additionally, when we do figure 4, it will have this next layer. Okay, so that was 1, 3, 1, 3, 1, 3, 5. We're expecting to have 1, 2, 3, 4, 5, 6, 7, which makes sense. 1, 3, 5, 7. Of course, you guys will do it a bit more neater than this, and you'll actually do it so that, I know, hey, it's a beautiful drawing. I mean, my artistic skills really are phenomenal. They're out of this world. You don't mess with my artistic skills. Like, they simply kill. Yeah, hey. Alright, so 4.2.2. Please, guys, figure must be obviously nice, you see. Like I said, 1, 1, 1. Okay. 3, 3. Yes. Additionally, to figure 4, it has 4. The third layer. The third layer has 1, 2, 3, 4, 5. You can see it's 1, 3, 5. So you're expecting that in the next layer, you'll have 7. Alright? Yeah. So I hope the geometric figure just makes sense. It says now complete the table A and B. Okay, figure N, figure 1 had 1. Figure 2 had 1, 2, 3, 4. Figure 3, figure 1 has 1. Figure 2 has 1, 2, 3, 4. Figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Figure 5, which is the one that we just drew. So what are we noticing about? It says the number of 1, 4, 9, 16, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. 16, right? So what's going to be happening with the next? It says the number of squares. Okay. I am Fifi will be doing grade 8 at 1 p.m. I just moved that session. Someone can actually... Okay, let's do this. Let's do this very quickly. Sorry. I'm sorry about that. It's just that the grade 8, 9 session, there's just so much I haven't covered yet, Grade 8 at 1 p.m. At 1. Just bear with me, people. At 1 p.m. Yeah, there's people that keep on wanting to join. Grade 8 at 1 smacking p.m. I'm sorry, people. I'm just trying to type this. I need to make Odirile one of my what you call. Yeah, so grade 8 at 1 p.m. guys. Yeah, so just bear with me there. Grade 8 at 1 p.m. Okay, so 14916. Something very important, number of squares. So something very important. Each position here, if you notice, is being squared. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. What are you anticipating here? 5 squared, 25. 6 squared, 36. Okay, so yeah, all right, so it's 25. A is 25. All right, yeah. Okay, so what you notice here is that they've squared each position. All right, so A here is 25, 5 squared. The last one, 6 squared, is 36. You know, so Loveline, please, if you want like direct specific help, and I'm just wondering, what grade are you talking about, Loveline? What grade are you talking about? Then it says, write down the rule to show the relationship between n and t. N and t. Write down the rule to show the relationship between n and t. So what would you say here? T is equal to n squared. All right. How on earth? Reese, that is funny. What did you just find yourself here? Okay. So T is equal to n squared. Okay. The rule to show the relationship between n and t is that the number of squares, which is basically t, is equal to, so figure n represents the position. So what are we doing to the position of each term? The position, we are squaring the position. 1 squared to get the actual term. Okay. Okay, so that's very, very important. Very important. Okay, let's go on, guys. Study the table below. We've got another question here. Study the table below. Length of call in minutes: 0, 1, 2, 3, 4, 5. This is the length of call in minutes. Cost, rands and cents. Okay, so it's very important to know what are we actually dealing with here. So this is another direct or indirect proportion question. So let's see, length of call. What's happening with the length of call? 0, 1, 2, 3, 4, 5. We are increasing. Cost in rands and cents. What's happening with the amounts? 0 rand, 1 rand 50, 3 rand 50, 4 rand 50, and so it goes. So we are also increasing. So as one quantity increases, the other one does what? It increases. Yes, this is a past common paper for grade 9, but this was written last year. This is Eastern Cape Province though, okay, because it was an actual paper. This was not a GEC paper. Okay, so worry not. Okay, worry not. Oh, we want a screenshot. So I'll be sending, I said to you guys, I'll actually be posting this. I'll post pictures of this as a video after I'm done. Okay. It's Sihu. Yes, I will definitely be doing that. Okay. Okay, so let's come here. So this quantity at the top is increasing. This quantity at the bottom is also increasing. Okay, so as one quantity increases, the other one increases. So what type of relationship is the data in the table above? Direct or inverse or indirect proportion? Come on, give me the answer. Direct. Oh, Riz, mess around. Yes, direct proportion. I explained earlier on today that direct proportion, as one quantity increases, the other one increases, or vice versa. As the one quantity decreases, the other one decreases. All right, are we together? But inverse proportion, on the other hand, as one increases, the other one decreases. All right. 4.3.2, find the missing values of A and B. Now, this is where we need to be very cautious what we do. Because remember, with indirect proportion, we wrote the quantities as products. But now with direct proportion, we don't write the quantities as products. We write them as fractions or ratios. This is grade 9 maths, Kayla. So please, people, very important. Okay, so we're gonna check this out. Look at this. This is what we don't have. Okay, but we have all of these. So basically, we can take what we have here. So what I'm gonna do, you see this 4 and A, I'm gonna write it as fractions. But what I don't have, I'm going to write in the numerator and then A over 4. Please, people, I'm setting up my fraction in such a way that the unknown is on the left at the top, so that my fraction has the unknown at the left at the top, which is very important. So I'm going to say A over 4. What is another one I can set up for my fraction on the right hand side? So if I said A over 4, let's take for instance 4 rand 50, all right, because that is going to be at the top, and then at the bottom we're going to say over 3. Okay, so remember I said the quantities are not products this time round, but you divide them. Okay, so like I said, length of call in minutes is one quantity. Okay, what's happening to the quantity? 0, 1, 2, 3, 4, 5B. So this quantity is increasing. Then cost rands in cents is another quantity. What's happening to it? 0 rand, 1 rand 50, 3 rand, 4 rand 50. It's also increasing. So as this quantity at the top increases, this one also increases. So what type of proportion is this? It's actually direct proportion. Now, since it's direct proportion, we are then now to find the missing values of A and B. We are going to write our quantities as fractions. In other words, as quotients of each other. Remember, the word quotient means divide. Okay, so we're going to write the quantities as quotients. All right, and then our unknown that we are looking for, we deliberately go ahead and write our unknown at the left at the top to set up our first fraction. So at the left at the top, A, which is this, over 4 is written as our first fraction. Then we can choose any two of these. All right, so 4 rand 50 for instance. Okay, 4 rand 50 and 3 is what I'm going to choose, which means I'm going to write this as a fraction on the right. So since I started with A at the top, this means 4 rand 50 is going to have to also be at the top for the other fraction. It's going to be 4 rand 50 over 3. So there it is, 4 rand 50 over 3. So now I have A over 4 is equal to 4 rand 50 over 3. Then what I do is I cross multiply, or in other words, what you would say mathematically is you actually multiply both sides by 4 to get rid of the 4 in the denominator. You multiply the numerator both sides. Okay, why are you doing that? You want to get rid of this 4 so you can isolate A. We do this deliberately. So hence I'm saying you set up your fraction. If it's direct proportion, you set it up in such a way that your unknown is at the left at the top. Okay, so like I said, A over 4, and we are consistent, right? The second fraction we take, because I took 4 rand 50, this means this is also, this 4 rand 50 is going to be at the top for the other fraction on the right side, and then the 3 is going to be in the denominator. I do that deliberately, deliberate, so that I can just simply, after setting up my fraction, I can just cross multiply, and this is what you have, 4 rand 50 times 4 over 3. Then I take my calculator, I just press this in. Sure, just press that in. 4.5 4.50. Very important. Don't say 450. 4.50. You times it by 4. Then you divide by 3. You get A, which is 6. You go back and check. Does it make sense that A is 6? Yes, it does. All right. Yeah. What I love here is that this thing is just saying find the missing value. Could you find the missing value without actually going through the calculation? Oh yes, definitely you can. What do you notice here? It's going up by 1 rand 50 every time. I'm sure you can see that. 0 to 1 rand 50. 150 to 3 rand, it's going up by 1 rand 50. 3 rand to 4 rand 50, it's going up by 1 rand 50. So 4 rand 50 plus 1 rand 50, you get that A. You could get that A because it is the fourth minute, okay? And then the fourth minute, the corresponding value would be 6 rand. So this makes sense. Makes perfect sense, even as per my calculation. All right. Then B. If you look at this, 7 rand 50. Okay, you add 1 rand 50, you get 9 rand. So that means B, even without using the calculation or doing the calculation, you know that B is actually equal to what? It's also equal to 6. But let's just do the calculation so that you guys can appreciate the calculation, right? So like I said, you set up your fraction in such a way that your unknown is at the top, at the left, all right? And then you just go and select any other one. Maybe you can select this one. Okay, remember that B is the one at the top. That means 5 needs to also be at the top. So 5 will be at the top over what? Over 7 rand 50. Please remember, people, this applies to direct proportion. You set up as a fraction, division, divide. But if it was indirect, it wouldn't be divide. It would be multiplication of these two equals to multiplication of these two. Okay, so this is the concept behind direct proportion, divide. Indirect or inverse proportion, multiply of quantities. So 5 times 9 rand divide by 7 rand 50. You take your calculator, you punch it in. We already expect the answer will be 6, but let's just do it anyways as per formality. Okay. Yeah, there we go. The answer is 6. So B is really 6, even per our calculators. Okay. Here it says find the missing values of A and B. Okay, so I mean, there would be nothing wrong if we just simply say A is 6 rand, and then we say B is equal to 6. And we write the unit, right? We don't just write the number, but we write the unit so that we can actually, appreciate the fact that my A value is an amount, it's rands and cents, and then my B value, maybe get just to be consistent, because you can see the 9 rand was written as 9,00, the 0 rand was written as 0,00. So also let's just be appropriate and write the A as 6,00. Then our B, these were all whole numbers, right? So B here in this case is actually equal to 6. We don't write it as 6,00, just so that we can maintain the most absolute accuracy in our sketch. Okay, guys, now we are here at graphene linear graphs. Okay, all right. Complete the table using the given equation. Plot the points on the provided Cartesian plane. Hopefully we all know what a Cartesian plane, the y-axis here, the x-axis here. What's beautiful is that the graph paper has been provided, so all we need to do is just sketch. 6m, what's 6m? Oh, very nice. I love you, Dikaye. You are a champ. Dikaye is a champ for years. Dikaye, you are amazing. So yes, Utigayo is very accurate in saying, question mark, why can't we just write 6m? Yes. Okay, and maybe length of call 6. Sorry. Sorry.
It's
I
okay.
meant to accept that. Sorry. So yes, guys, yes. Beautiful. Tigaya, thank you. You saved us there. You saved the country. You saved the nation. You're the man. You're the goat. You're the goat. That's for sure. So we write 6 minutes there so that we can be as accurate as possible. Guys, my next unnetworking. All right. Okay, I think we got it there. Unnetworking. All right. Okay, I think we got it there. Okay, let's go. Complete the table using the given information. Plot the points on the provided Cartesian plane. Join the points to form a straight line. Equation y is equal to negative 2x plus 1. So y is equal to, the gradient is negative. So what are we expecting? We're expecting that the shape of the graph, when we sketch it, is going to be in this direction. Remember, when m is less than 0, that's the direction of our straight line. It's a straight line that's decreasing, right? Because the gradient, the value of m is negative 2. Let's take note of that, because when you draw your sketch, if you are going to have something that is not a reflection of this, you must begin, as you about to sketch the graph, you must begin already having an idea in your mind how the sketch is supposed to look like, right? So this gradient, negative 2, tells us that it's supposed to be a decreasing straight line. So let's check this out. X is equal to negative 2, negative 1, 0, 1, 2. When we substitute x is equal to negative 2 here, really, negative 2 times another negative 2 is positive 4. 4 plus 1 is 5. That makes sense. Negative 1, we substitute negative 1 in the place of x. Negative 2 times negative 1 gives us positive 2. Positive 2 plus 1 is truly positive 3. That makes sense. Moving right along, you take 0, you substitute in the place of x. Negative 2 times 0 is 0. Plus 1, you have 1. You take 1, you substitute in the place of x. Negative 2 times 1, that gives you negative 2. Negative 2 plus 1, negative 2 plus 1 gives you negative 1. And then last but not least, if you take 2, you substitute in the place of x. Negative 2 times this positive 2 gives you negative 4. Negative 4 plus 1 gives you, I'm going to wait for it. I'm going to wait for that answer for someone to actually say it. Beautiful Z. H. Anele, beautiful. Shabangu, awesome. Katlejo, beautiful. Talkative boy, phenomenal. Olivia, amazing. So yes, it's a beautiful talkative boy. Please just be careful, eh? Negative 3, not positive 3. Talkative boy. Okay. Less talking, more doing of maths, talkative boy. Otherwise you're gonna miss out on some important information there. So negative 2 times this positive 2 gives you negative 4. Negative 4 plus 1. People, please, your calculator is there for the using. Yeah. So very important. Then we can use these. We call these, okay, minus 2 and 5. We call it an ordered pair. X coordinate, Y coordinate. Then we have minus 1 and 3, the other ordered pair. Then we have 0 and 1, the other ordered pair. 1 and negative 1, another ordered pair. 2 and negative 3, another ordered pair. We use these ordered pairs to then identify in our Cartesian plane the points that we need. So negative 2 is for x. It's like when your mom. 5 is for y. So we go and identify 5 here. We have 2, 3, 4, 5. So when your mom and your dad were living worlds apart, and then somehow your mom and your dad, they met and fate had them meet. That's the point where they met. Negative 2 and 5. Negative 1 and 3. Negative 1. Three, 4, 5, 6. What's happening here? Okay, let me just understand something here. Yeah. Sorry, guys. There's something here that I'm actually seeing. You see, not reading or not getting. So what is this? So let's just check the working of the graph. Not 0.5, 1, 1.5, 2. Oh, it's going up by 0.5. Are we together now? Hey, I'm sorry, guys. Wrong. Okay, I know I have people that are alive and well in my life, and they are not just sleeping, so that's very cool. That's very good. Okay, so -2, that's powerful, right? That -2. Your mom was still there anyway, so mom is still here. Okay, then dad, we just need to identify dad properly here. So here, that is 2.5. Oh, okay. All right, so that's 4.5. What is happening here? 4.5, 5.5. So that's 5. So that's 5. 5 is here. So this is where they were supposed to meet. I'm sorry, guys. This is where we are supposed to have met. This is the point. My bad. Brakoki, I made a bad mistake. Terrible mistake. Okay. No. I'm glad you guys are here so that you can help me out. So that's there, hey? That's 5. So it's 4.5, 5, 5.5, 6. So that's 5. 5 is here. Brilliant. You guys are phenomenal. So we are here. So that's -2 and 5. That is the point. Okay. Then we move right along. -1 and -3. So we have 0, -0.5, -1. So -1 is here. Where they meet, -1 and 3. Where's 3? So 2.5, 3. All right, so we need to understand our workings of the graph here. So this is the other point. Okay, -1 and 3. Very important. Then we move right along to the next one. Reese, thank you so much. That's very kind of you. Then 0 and 1. X is 0. X is 0. So X is 0. That's everywhere on our y-axis. X is 0 everywhere on our y-axis. But then we go to 1. 1 is here because this is 0.5. That's 1. Y for 1 is here. Okay. Then we move right along. 1 and -1. Where X is 1. So 0.5, 1. 1 is here. And then Y is -1. We have -0.5. We have -1. So we are here. So 1, okay, and -1. So are we meeting? We are meeting exactly here. This is 1, and then -1 is here. So we are meeting exactly here. Makes sense? So we are here. Then last but not least, 2. X is 2. Where X is 2, we are here. Where Y is -3. So we have -2, -2.5, -3. So -3 is here, but 2 is here. That's where we meet. 2 is here, -3 is here. That's where we meet. Then what you do is you take your amazing ruler, which unfortunately I do not have. Then you connect these beautiful lines together. You use your ruler, please. Use your ruler, guys. You use your ruler and you connect with everything. Okay, I'm gonna start over. Don't worry. Start over with everything. You mean the sketch of the graph. I can start over for the sketch of the graph, guys, but starting over with everything, as in like from the beginning, that will not be feasible given my time constraints. But like this is how we would go about sketching the graph. So like I said, we were first able to do what? We were first able to identify X, -2, Y was 5. Then X was -1, Y was 3. X for 0, we substituted the 0 here, and then we were able to get Y is 1, and so forth, and so it goes. Then after that, what did we do? We identified the points, right? -2 and 5. We were able to go to our sketch and check where is X for -2. X for -2 is here. Then Y for 5, all right? It was here. Then we go where the 2 points, they meet. We meet here, all right? Okay. And so it goes. Then after doing that, we were able to connect. We saw that the points we identified, then we connect the dots using a ruler. Please, people, use a ruler because this is supposed to be a straight, amazing line. Don't mind that mine is not, but this is supposed to be a straight, amazing line connected by the ruler. All right. And then you are able to actually have that straight amazing line. You can see that the shape of it's taking on this form because the gradient was less than 0. Okay, and then we can actually line and identify and write the equation of that line. Y is equal to negative 2x plus 1. Okay, all right. And Dax, when I start over, Dax is saying, when I start over, call me, you're killing me. You're killing me softly. Okay, how many marks is that? 6 marks. 6 marks. Why? Because there's marks that are attached to finding the points for your table, right? All right, and then after that, there's marks that are attached to actually identifying the points and drawing the straight line. Okay, so identifying the points, drawing the straight line as well, then that's basically it. Okay, when am I going live again? At 1 p.m. I'll be going live again, but it will be for grade 8s. I'm actually now just trying to push through this session up until I guess 10 half past 10. Yeah, so yeah, I won't be able to start off at page 1 at the moment because, like I said, we've kind of like pushed through. We've been here for a while, for those that have been here for a while, but I will be doing maybe a repeat session maybe later on, maybe let's say tonight, right? Yeah, later on tonight. Okay, so let's come here. Determine the equations of each of the following graphs. Okay, now the equations of each of the following graphs, very, very important. Do we all know the gradient formula? Have we all learned the gradient formula? Okay, hopefully we have. So first and foremost, the equation of a straight line can be given by the form y is equal to mx plus c. All right, now I want to get a bit closer here. We have a y-intercept here, it's 2, all right? And then we have a x-intercept here, all right? And it is negative 4. Hopefully you can see that now, all right? So y is equal to mx plus c is basically what we refer to as the standard form for a straight line equation. Very, very important, okay? And then I asked you guys the question, do you guys know what the gradient formula? Do you know the gradient formula? If you want to calculate the gradient, is that a formula you guys have been taught in grade 9 in your respective schools or not? Okay, just something I wanted to ask for where that is concerned. But nonetheless, let's forgo that for now. So if we go and write down the equation, we want the value of c. Now the value of c we know is the y-intercept. So you know the equation, I mean the formula for gradient. That's crazy. Okay, anyways, so the y-intercept is 2, right? So the y-intercept here is 2. What is the y-intercept? It is where the graph cuts the y-axis. All right, so this is the y coordinate. 2 is the y coordinate for the y-intercept. Okay, z, that's beautiful. Change in y over the change in x, and this is grade 9. Okay, beautiful. I'm happy you guys have learned such. All right, so I'm gonna do this question in 2 ways. Okay, so if you have the y-intercept, what's easy about that is that you can actually go ahead to the formula and say y is equal to mx, and then in the place of c, you are going to substitute the y value of the y-intercept, which is, in this case, is positive 2. Hope that makes sense. Then you can take another point on your straight line that you've been given, which in this case is the x-intercept. Do we know what the coordinates of this point are? I hope we all know that this is -4 and 0. So what you're going to do is you're going to substitute -4 and 0. You take the other point. This is x, this is y. You substitute 0 here. X -4 plus 2. And then you solve for m. So you take the plus 2 over, you get -2 minus 4m. Then you divide both sides by the coefficient -4. Then your final answer for m because negative 4 divided by negative 4 gives you m. What's negative 2 divided by negative 4? You get a positive half. Therefore, what's the equation? Y is equal to m half x c plus 2. That is the equation of the straight line, right? So this is when we use the y-intercept and the other point to find m. So we use the y-intercept, we substitute the value of y for the y-intercept in the place of c. It's positive 2. If it was here and it was a negative number, we'd substitute that negative number in the place of c. Then we use the other point whose coordinates we need to be clear about, substitute it, and then solve for m, the unknown. Then we get the value of m. Please, people, by now I'm hoping all of us can solve for an unknown variable. So for instance, transposing by 2 over, it becomes negative 2. Then dividing both sides by the coefficient, the number before the variable, on both sides, and then getting the value of m, which is half. Then the equation we need to write, because that's what we were asked. Y is equal to half x plus 1 plus 2. Clear? So clear. All right. Alternatively, you could have used the gradient formula. M is equal to y2 minus y1 over x2 minus x1. So this is just for others. Please, guys, don't forget to support my live goal there, with all intents and purposes. It would be great. Yeah, share the live definitely. So we could have used the gradient formula, identified the coordinates for both points. We have minus 4 and 0, and we have 0 and 2. People, let's not make the error of saying this is 2 and 0. Remember, this value of 2 represents the y value, so it's the y value is 2. Here x is 0, please. Then here the x is negative 4, but the y here on the x-axis is 0. Let's not make the error of writing things haphazardly, right? So we have y2 minus y1 over x2 minus x1, the change of y over the change of x. First pair of coordinates, if you choose, then you say x1, y1. Second pair of coordinates, this is x2, y2. Then what do? We go and substitute into the gradient formula what we've identified. So what is y2? Y2 is 2. What is y1? Minus 0. What is x2? 0. What is x1? There's already a minus sign in the formula, so I write that down. But x1 is negative 4, so I write that in brackets. Here I repeat, the sign in the formula, there's already a negative sign, but x1 is also negative, so you put the bracket. 2 minus 0 is 2. 0 minus minus 4. 0 plus 4. So it's 2 over 0 plus 4 is 4, which is a half. So that gradient m really is still half if we use the gradient formula. Then we go and write the formula. Y is equal to mx plus c. Y is equal to m we found is half. C represents the y-intercept, and according to our graph, what is the y-intercept? The y value of the y-intercept is 2, which means C is positive 2. That is it. So you have two methods that you can utilize. You can either use the method where you first calculate the gradient and then you find the y-intercept, and then you substitute the y-intercept. Or you can go ahead and substitute the y-intercept. Then you use another point on your Cartesian plane, substitute it, and then find the value of m. And then you get the equation or the function y is equal to half x plus 2. Moving right along and not too fast, this question It's fine, Katlego. You use the method that is appealing to you. Me, I just thought, let me expose you anyways. This question, all right, the following one is a straight line, but this straight line, unlike other straight lines, is actually a vertical line. Now, this is where things get very interesting for most people. And we have a lesson again today, late, please. Yeah, we'll do it, just calm down. Am I going to be doing translation? What translation now? What are you talking about, Rich? Translation for what? So negative 2, okay. Then here, this is a vertical line. It's negative 3. And then here we have negative 4. All right. So here, this is a vertical straight line. And any vertical straight line, unlike a straight line that has a positive gradient and negative gradient, okay, a vertical straight line is the only straight line that uniquely has the equation x is equal to some constant value. And that constant value that's there, all right, that constant value that is there is always the value of x that vertical straight line cuts through, right? So I know for a fact that the equation of this line is x is equal to, what is x equal to? Since it's a vertical line, x is equal to, what is the constant that this vertical line, what is the x value that this vertical line cuts through? So it's very clear that it's midway between the negative 2 and negative 4. That's negative 3. That means x is equal to negative 3. That's for 1 mark, guys. Okay. So a vertical straight line is the only line that basically has x is equal to some constant. All right. Whereas a horizontal line, on the other hand, has y is equal to some constant. Okay. So let's be very vigilant and clear about those, because the answer can simply be written by looking at the function and then writing the answer. Guys, I'm going to move right along, okay, because I'm really pressed for time now. It's really like getting a bit more crazy. Question 6, and I need to leave. Simplify and give answers with positive exponents. So let's not forget the laws of exponents where these questions are concerned. A to the power m times a to the power n. When the bases are the same, what do we do to the exponents? We add them. That's law 1. Law 2, a to the power m divided by a to the power n. When the bases are the same and we are dividing, what do we do to the exponents? We subtract them. Okanye, a to the power m raised to the power n. When the base is raised to a certain exponent and it's raised to another exponent, what do we do to the exponents? We multiply them. If there are 2 respective bases, but it's one term, right? These are combined. It's one term. This is also one term. This exponent can be appropriately applied by multiplication in the same fashion. A to the power m times p. P gets distributed to the m times b to the power n times p. P gets distributed to the n by multiplication. And then also here, when there's a relationship of divide between the bases opposed to a relationship of multiply between the bases, we do the same thing. The base, the exponent gets multiplied to the one that's outside. B to the power n gets multiplied to the exponent that's outside. So these are important, okay? These are like things that we need to know where exponents are concerned. And if we know them well, we can apply them. So we are here now. A squared b times a to the power 3b to the power 4. So simplify and give answers very important with positive exponents. So let's go. A squared b times a to the power 3 b to the power 4. What does that mean? It means a to the power 2 plus 3 b to the power 1 plus 4. Finally, a to the power, what's 2 plus 3? It's 5. What's 1 plus 4? 5. So here's the thing. This is a squared b times a to the power 3, b to the power 4. We are multiplying here. A squared. So we keep the base because the relationship between all of these bases is multiplication. So what are we going to do? We're going to keep the base for same bases and add their exponents. So a to the power 2 plus 3 combined with the base b. Remember, there is a 1, and sometimes, too many times, people don't forget that 1. So it's 1 plus 4, the exponent, because the bases are the same for b. You add the exponent, you get b to the power 5. Make sense? A to the power 5 times b to the power 5. Okay, let's move right along, guys. Move right along. 2x squared times 8xy to the power 3 over 4x to the power 4 y to the power 2. Very, very important. So what I'm going to do here is 2x squared times 8xy to the power 3, 4x to the power 4y squared. Look at the top first. We multiply. We apply S and L when we multiply. Meaning we multiply the signs. 2 times 8, they are both positive respectively. Positive times a positive is positive. What's 2 times 8? 2 times 8, the number is 16. So signs done, numbers next, then letters next. X squared times x. That's x squared plus 1, obviously. Then y. Y is not having another variable y on for this particular base. So basically that's 16x to the power 2 plus 1y to the power 3 over 4x to the power 4y squared. So let's formalize this. This is 16x to the power 3 y to the power 3 over 4x to the power 4y squared. Now that's nice because now we actually have one term at the top, one term at the bottom. Then we can divide, applying S and L again. Divide the sign, divide the number, divide the variable. Divide the sign, number, letter, sign, number, letter, sign, number, letter. 16 divided by 4, okay, is equal to 4. All right? Yeah, in other words, between 16 and 4, the highest common factor is 4. 4 goes into 16 4 times. So there's a 4 in the numerator. Okay, and then 4 goes into 4 how many times? Once. So I'm going to write the answer as 4 over 1. Does that make sense? That's why it's 4 over 1. Then x to the power 3 over x to the power 4. This is x to the power 4 minus 3. No. 3 minus 4. Okay, so there's two things here. All right. Okay, maybe what I can do here, there's two things that you can do here. Okay, in grade 8, grade 8s don't usually do they don't do negative exponents. You only get exposed to negative exponents in grade 9. So in grade 8, usually what is taught whenever they have a situation like this. Okay, so we start with the number 16 divided by 4. Okay, 4 goes into 16 how many times? 4 times. And then 4 goes into 4 how many times? Once. Then here for grade 8s, usually x to the power 3 over x to the power 4. This base here is x to the power 3. We will actually make it join the denominator exponent. And how we do this is we say x to the power 4 minus 3 in the denominator. It goes back to that law of exponents, because when the base x comes to the denominator, its exponent will change, right? From positive 3 to what? To negative 3. So it will be x to the power 4 minus 3 in the denominator. Does that make sense? Then y, what about y? Y is to the power 3. No? The big guy is always joined by the small guy. It's like in the same thing here. The big guy is joined by the small guy. But when the small guy comes down, his sign changes. The big guy, for same basis, the big guy 3 is joined by the small guy at the top. His sign changes. So it becomes 3 minus 2. and then finally you get 4 over 1. Now the y in the numerator, 3 minus 2 is actually equal to 1, so we have y to the power 1. Then in the denominator, what's x to the power 4 minus 3? That's x. So our answer is actually 4y over x. All right, so for grade 8s, you know, yeah, this thing of moving the positive small exponent to join the big positive exponent in the denominator, but when you move position from numerator to denominator, your sign changes. Same thing here. The base variable y, because the base are the same, the law says 3 minus 2 in the numerator. Obviously, when this changes position, it becomes negative at the top. Okay, so that's very important. Then that leaves us with that answer, 4y over 1x. Okay, guys, I'm moving quite swiftly here, so you just have to bear with me. Cube root of 216. Cube root of 216, guys. Cube root of 216, very important. So basically, the cube root is going to be applied to 216, and then the cube root is going to be applied to x to the power 3. When we apply it, I'm sorry, this is kind of blurry. I don't know why. Focus in, guy. Come on. Sure. Okay, there we go. The cube root is applied to 216. If we apply the cube root to x to the power 3, then it's 3 divided by 3. Okay, because for that one term. Remember, we apply the cube root to the sign, we apply it to the number, we apply it to the letter and its exponent. So it's 3 over 3, all right? Then minus 16x. Okay, what's the cube root of 16? Okay, if we don't know that, please, people, go to your calculator, all right, and please shift cube root to 16. Don't say the square root, don't make that mistake. There we go, we got 6 if you don't know it. 6x, then 3 over 3 is 1. So we have 6x minus 16x. And these are like terms, all right? So we definitely get a mark here for having this 6x. 6x minus 16x, all right? So these are like terms. We add and subtract the coefficient. The variable stays the same. So 6 minus 16 is negative 10, which gives us negative 10x. Okay, moving right along, simplify the following expression. People, hopefully I know you know this is, we apply FOIL here, meaning we multiply this is a binomial by a binomial. So we multiply the first term, outer term, inner term, last term. And we apply SNL as we multiply these things out, right? Yeah. No, definitely, Katlego. Definitely. So x times x, bases are the same, that's x squared. X times 4, positive times a positive is positive, 1 times 4 is 4, and then the x. Then negative 10 times x, negative times a positive is negative, 10 times 1 is 10, then the x next door, then last but not least, negative times this positive 4. SNL means sign, number, letter. Whenever you multiply, you first multiply the signs, then you multiply the numbers, then you multiply the letters. In other words, the variables. Okay, that's what SNL means. You multiply first the signs. So for instance, if I'm multiplying x times x, I need to take into consideration what's the signs of x and x. They are positive, both of them. A positive times a positive gives me a positive. Then what are the numbers before x and x? It's 1 times 1, which is 1. And then what are the letters? X times x, which is x squared, because I keep the base 4 variables that are the same when I multiply, and I add the exponents. Then moving right along, x times 4, same thing. We apply SNL, sign, number, letter. Positive times a positive is positive. 1 times 4 is 4. Then the letter x times x is alone, so x is just a variable that's there. Again, minus 10 times x, minus times a positive, negative. 10 times 1, because there's a 1 before the x, that's 10. And then x next door. Then last but not least, minus 10 times 4. Apply SNL, meaning you multiply the signs, you multiply the numbers, you multiply the letters. Sign, number, letter, sign, number, letter, sign, number, letter. Negative times a positive is negative. 10 times 4 is 40, right? Then here you look for the like terms and you add it. So x squared, what's 4x minus 10x? Remember, when we're adding like terms, we keep the variable, we add and subtract the coefficients. What's 4 minus 10? That's negative 6. Guys, if you don't know what the addition of those numbers are, there's no crime in just taking your calculator and please go ahead and say 4 minus 10, because the last thing you want to do is butcher the middle term simply because your signs are incorrect. You think that 4 minus 10, I don't know, is 14 maybe, or it's 6, that's positive. We can't afford to make those kinds of mistakes. So negative 40, so that's our trinomial that we get. Hopefully you were doing it along with me. The 3 marks in the bag. You know, x squared is correct, 1 mark. Negative 6x is correct, another mark. Minus 40 is correct, the other mark. That's given that they can see that you have the previous step that's there to show that you applied for it. Okay, 2x minus 4, the whole thing squared. Be very careful with this one. 2x minus 4 into 2x minus 4. This is what you need to do first, because this is 2x minus 4, everything squared. I'm going to do grade 11 tomorrow too high. Okay, I'm going to post a poster later on today just highlighting what times and days I'll be doing certain sections, because this is something I'm kind of starting off. So like, I've never seen so many people on my live doing a maths lesson. This is like my second, probably third live lesson I'm doing ever. So tomorrow, in actual fact today, you can expect a poster to be up that will be telling you what's cooking. Katli, you are amazing. I see you already have the answer answered out. A common error that learners tend to make is that they usually think that you apply the square to 2x, you apply the square to minus 4. So they get like 4x squared plus 16 and they think that's the answer. No, please, this is a binomial inside the bracket. That means you need to open 2 brackets and apply FOIL. Are we together? So let's do it. Apply FOIL and use S and L. Does that make sense? I will post this paper, don't worry, Moika. 2x times 2x, 4x squared. 2x times minus 4, negative 8x. Minus 4 times 2x, negative 8x. Okay, as I do this, I'm applying S and L. 2x times 2x, positive times a positive is positive. Sign done. Number, 2 times 2 is 4. Number done. X times x, applying the letter, the variable exponent. When the bases are the same, I keep the base, I add the exponents, x squared. Move on to the next one. 2x times negative 4. 2x times negative 4. Positive times negative, negative. 2 times 4, 8. X is the only variable, I put it next door combined. Next one. Minus 4 times 2x. Negative times a positive, negative. 4 times 2, 8. X next door. Then last but not least, minus 4 times minus 4. Negative times a negative is positive. 4 times 4 is 16. Then you add your beautiful, amazing like terms. Negative 8x, negative 8x. Use your calculator, people, if you know you are going to butcher the minus 8, because hey, minus 8. minus 8 is minus 16. You keep the variable. And that is that. Okay, yeah, so currently negative 12x. Yeah, I think somewhere somehow there was something that you may have omitted to do. I don't know if you said minus 4 times 2 is negative 6. You may have done that, and that's such a common error. Minus 4 times minus 2, 4 times 2, people think it's 6, and sometimes the brain doesn't work. That's why I get this boy, this guy, this man, this is the only man. If you're a young lady, this is the only man you need to be keeping in your life, very close and near and dear to you, and make sure you make use of him. Otherwise, yes, Katli, you definitely did try, and I commend you for that. I mean, the first person to respond, so that speaks to like the speed at which you go. But just make sure that when you do the maths, that you get it right. Okay, Yo boy Tina, how did you get the 2 minus 8? Okay, all right, so just a repeat again. 2x minus 4 into 2x minus 4. Remember, when I multiply the first terms, 2 times 2, I got 4. X times x, I got x squared. Then when I say 2x times minus 4, 2x times minus 4, sign, number, letter. If you multiply the signs first, positive times a negative gives you a negative. Then 2 times 4 gives me 8. Are you with me? And then the x. Okay, I first multiplied 2x times minus 4. Then I went again and took this term and multiplied it with 2x. Negative 4 times 2, same thing. Negative times a positive, another negative. 4 times 2, that's 8. And then the x next door. Are you with me? Next door. It's the only x variable there. Then the last term, negative 4 times negative 4 gives me positive. 4 times 4 is 16. Then when I add these like terms, negative 8x with negative 8x gives me negative 16x. Hopefully that makes sense and you're clear now. Okay. All right. And then I think we are down to the very last in papier. Is that true, Bob? Or like, am I just mistaken? Okay, I'm gonna need a serious maths detox after this, because maths for the morning like this. Guys, don't forget to support me in my live goal there. I'd really appreciate that support all the way, all the time. It does help me out. Also, I think my connection here is becoming more and more unstable as we continue. Okay, this is kind of like rolling down to the last innings of the paper. Okay, so here the very last few questions. Okay, 4x cubed minus 2x squared minus 8x over 2x. So this is a typical question where you have 3 terms in the numerator and a 1 term in the denominator. So when we have a situation like this, all right, guess there's 2 approaches that you can have. You could factorize the denominator. You could factorize, the numerator, take out the common factor, and then cancel out, or you could split the fraction. All right, so I'm going to look at both methods. Let's just look at both. So let's start with because in the numerator you can see there is a factorization we could do. There's a highest common factor that we have there, so we could factorize. It's possible to do so. So I'm going to look at the factorization in the second method. So this method that I apply now is the splitting. Okay, so meaning I split 4x cubed over 2x, 2x squared over 2x, and minus 8x over 2x. Then I divide and apply S and L. What does that mean? I apply S and L, meaning I divide the sign, divide the number, divide the letter. Positive divided by positive is positive. What's 4 divided by 2? The highest common factor here is 2. 2 goes into 4 2 times. 2 goes into 2 once. Then x cubed over x. That's x cubed minus 1 if I apply the laws of exponents. Okay, then the next fraction, negative times divided by a positive gives me a negative. I will post the paper, don't worry. Like I said, 2 divided by 2 is 1. And then x squared over x, that gives me x to the power 2 minus 1. Then last but not least, negative divided by positive is negative. 8 divided by 2 is 4. And then x divided by x is x to the power 1 minus 1, which is actually 0. X to the power 0. So finally, we have 2x squared minus, okay, let me just write that 1 minus 1 so that you can see that, minus x to the power 1 minus 4x to the power 0. But remember, the to the power 0 has been applied, or is supposed to be applied to the x alone. So that means 4 times 1, which finally is actually the answer, 2x squared minus x minus 4. One x 2 minus 1. Okay, how did I get that? Remember, there's a law of exponents that says when the bases are the same and I am dividing, I subtract So the bases are the same. What do we do when the bases are the same? Okay, a to the power m divided by a to the power n. What do I do when the bases are the same? I keep the base and I subtract the exponents. I hope that makes sense. Okay, so that's how you are able to get x squared divided by x. The bases are the same, so you keep the base, all right, and then the exponent 1 joins the exponent at the top and you subtract. So x to the power 2 minus 1 is where that comes from. Okay, so this is one method where you split the fraction, especially when you have one term in the denominator. You can split the fraction and then use the division, applying S and L to simplify. Or, like I said, alternatively, you could factorize. You could use the factorization method. Okay, so the answer is 2x squared minus x minus 4. That's the answer. Okay, this was the approach. Thank you, BB, for the rose. I really appreciate it. I appreciate the support. Thank you so much. So yeah, you split first the fraction. You have one term in the denominator. So that means you can split the fraction 4x cubed over 2x minus 2x squared over 2x minus 8x over 2x. This you can only do when there's one term in the denominator, this whole splitting of the fraction. Then you apply division and you apply the exponential laws as you divide. So you can do that only with that situation. You cannot do it with when there's two terms in the denominator and so forth. So I hope that makes sense. All right. Then, like I said, there's the factorization method. So I'm going to show you the factorization method just now. Okay. So you have 4x cubed minus 2x squared minus 8x. So you take the numerator, because you can see there's factorization that you can do. 4x cubed minus 2x squared minus 8x. What is the highest common factor? The highest common factor for a number is basically the highest common factor, the number that fits in, the highest number that fits into 4, 2, and 3, right? The highest number that fits into all of these numbers and leaves no remainder. So the highest number that fits into all three of these numbers is actually 2. 2 fits into 4 twice, it fits into 2 once, it fits into 8 4 times. Then if you look at x to the power 3, x squared, and x, the highest common factor for a variable is always the variable that has the lowest exponent if the bases of those variables are the same for all the terms. All right. So if you look at x cubed, x squared, x, the highest common factor variable, okay, x cubed, x squared, and x is x, because the x variable for all bases of x that are the same has the lowest exponent. So we take that out. There's no other highest common factor. Then, what are you left with inside? 2 times what gives me 4? It's 2. Or in other words, what's 4 divided by 2? It's 2. Then x cubed. If I took out one x, how many x's do I need to add in order to get 3? I need 2 x's. Okay, please people don't, this is not relationships or anything. I'm just talking about x, the variable. Then same thing with this second term. 2x times what gives me a negative, so that would have to still be negative. Then 2 times what gives me 2, it's 1. Then x times what gives me x squared. So if I took out one x, how many x's do I need to get 2? I need 1x. And then last but not least, 2 times what gives me 8, it's negative 4. And then obviously there's an x that I took out already. There's a 1x that's supposed to be there. Do I need to put an x? Not even. So I leave that there like that. But remember, in the denominator I had 2x, so that's 2x there. Now people, when you are at this stage, what can happen is that you can now cancel 2x and 2x, which will lead you to 1. Why? Because we can cancel if it's not across an addition and a subtraction sign. The relationship between 2x and this bracket makes it such that what we have at the top is one term. Please understand, I'm going to repeat this. 2x into this bracket, the bracket makes it such that 2x and the bracket have a relationship of multiplication. Therefore, this in the numerator is one term. In the denominator, we also have one term. So cancellation can happen because it's not across. After this 2x, there's no plus or minus sign. It's a bracket, which means multiply. So I can cancel 2x and 2x because I can divide these two. And then what am I left with as a result? If I cancel these two, right? Please understand this. If I cancel those two, I'm going to be left with 1 and 1. Therefore, my final answer will be 2x squared minus x minus 4 over 1. But remember, to divide by 1, you can just simply write and maintain what you have in the numerator. And the 1, whether it's there or not, obviously we recognize it as being there if it's in the denominator. If it's in the denominator. Okay. Right, so that's that. I hope that is clear, evident for everyone. So those who did the factorization method to simplify this, you guys are spot on. Those who used the splitting method, the answer is the same, guys. Whether you used the factorization method where you factorize what's complicated and then you cancel out what's common in the denominator and the numerator only if it's not across an addition or subtraction sign, or you can obviously do the splitting method. Okay, now I'm going to wrap up, guys, because, yeah, hey, the time is coming that I need to bounce or vamoose, if you know what I mean. Use factorization and the zero product rule for the following. X squared minus 121 is equal to 0. So when you look at this, factorization, we have different types of factorization. We have highest common factor factorization, where we take out the highest common factor if one is available, and then we simplify in that fashion. There is difference of two squares. In other words, when we have the difference means minus, and then you have a perfect square on the left hand side and a perfect square on the right hand side. That's difference of two squares. Okay. You also have trinomial factorization. Yeah, trinomial factorization. When you have a trinomial and we basically factorize by opening two brackets, right? And then we also have, for highest common factor, there's also common bracket. Like when you have a common bracket and you take out a common bracket and you factorize, because you can see that the brackets are common, so you take out the common bracket. Okay, and then there's also grouping factorization. All right, so all of these are very important. We need to know these different types of factorization. So even before you are able to answer factorization questions, you need to know these types of factorizations very well, so that when you look at a question, you can quickly identify, but oh, okay, if I'm going to use factorization and solve for x, do I know how to factorize the expression that is on the left hand side? So what you see here is x squared minus 121. This here is a typical expression where we are supposed to actually use difference of two squares. What do you mean? There's a minus sign. X squared is a perfect square. 121 is a perfect square. Why do you know, Minier, that 121 is a perfect square? It's because I know my family of perfect squares, you know, which is very important. So here we go. What we do is we first factorize. We first make sure that our equation is in standard form, which means we have an expression and it's equal to 0. Now, since we identified this is difference of two squares, it means that the square root of x squared is x. We're going to have x on either side as our first term in each bracket. Then 121, okay, the square root of 121 is actually equal to 11. So we are going to have 11 and 11 on either side of the bracket. Because this is a typical difference means minus, of two squares. X squared is a perfect square, that's one perfect square. 121 is another perfect square. All right, so the square root of x squared is x, so I write x for my first term in each bracket. The square root of 121 is 11. So that's 11 for the second term in each bracket. And then last but not least, in order to get a minus sign, the two signs that are different that will allow me to have that is a positive and a negative sign, because a positive times a negative will give me the negative for my constant term. Then I say equal to 0. Then they said use the zero product rule. What is the zero product rule? The zero product rule simply says the following. If you have a product of two factors, and they are equated to 0, you can basically say that A is equal to 0 or B is equal to 0. So what do we have here? We have a product of two factors. What are those two factors? The two factors are x plus 11 and x minus 11. They are both equated to 0. So they fit the description of if A times B is equal to 0, then I take my A, I equate it to 0, I take my B, I equate it to 0. So I'm going to do the same thing here. I'm going to take my x plus 11 equated to 0 or x minus 11 equated to 0. Then I'm going to solve these linear equations respectively, which means x is equal to negative 11 or x is equal to positive 11. Okay, so those are my two answers for x. Okay, x is equal to negative 11 or x is equal to 11. So that is how we go about solving an equation of this nature using the zero product rule, or sometimes they refer to it as the zero factor law. X plus 11 is equal to 0 or x minus 11 is equal to 0. So x is equal to negative 11 or x is equal to 11. And really and truly, when you take this 11 and substitute it back into this formula, it satisfies the equation. If you take the negative 11 and substitute it into this equation, it satisfies the equation. All right, moving right along, x into x minus 7 plus 5 into x minus 7 is equal to 0. So this was a typical difference of two squares factorization on the left. Then by using the zero product rule or the zero factor law, I was able to solve for x. Here, what type of factorization can you see on the left hand side? X into x minus 7 plus 5 into x minus 7 is equal to 0. What type of factorization can you evidently see just from looking at the question? What do you see? What do you see? Okay, so hopefully we can see definitely orabile common bracket x minus 7 and x minus 7. How many terms are in the expression on the left hand side? How many terms are in the expression on the left hand side? How many terms, guys? How many terms? What is x? Jericho, what do you mean? Can I please explain what is x? What grade are you in, Jericho? Okay, thank you, Neo, Zanki, Nuri, Percy. You guys are spot on. There are two terms in the expression on the left-hand side. So that means if there are two terms on the left-hand side, then it means that, if I have a common bracket, I can take that common bracket out. So that common bracket that I can take out is x minus 7. So if I take out the x minus 7 on the left, I hide the x minus 7 on the left-hand side. What's left? What is left on the left-hand side if I take out the x minus 7? On the left-hand side, I'm left with, because this will compose my second bracket. On the left-hand side, I'm left with x, right? On the left-hand side. Then if I go to my other term, the common bracket that I took out, x minus 7, what am I left with on the right? I'm left with plus 5. That means that's my second term that I'm left with. Okay. Okay, and then equal to 0. Thank you so much, user 435, answering Jericho. Jericho, x is a variable, more like an alphabet, but in maths we say it's a variable. Yes, and that x it stands in the place of something that we do not know yet. But once we find it, then we can assign a certain value to it. So for instance here, x was something we didn't know, but the minute we solved the equation, x became something that we knew, that is minus 11 or 11. Okay, so thank you so much, user. I love the interaction that's happening down here, guys. Thank you so much. You guys are phenomenal. X minus 7 into x plus 5 is equal to 0. So that's basically how I would factorize that. X plus minus 7 was the common bracket. On the left, what was I left with? I was left with x. On the right, what was I left with? Plus 5. Then I can now use the zero factor law, because the condition to use the zero factor law is that there must be a product of factors equated to 0. Then I can take each respective bracket equated to 0 and solve. So x minus 7 is equal to 0, or x plus 5 is 0. Then x is equal to, I transpose the minus 7, it's 7. Or x is equal to, I transpose the 5, negative 5. Answer gotten. All right. Okay, and then the very last question that this paper had. All right. This is not to say that the paper that I have posted is basically the paper that you might, expect to get. No, it's just that this is kind of like a picture of what could possibly be there. All right, and this is also, I'm trying to really help people to understand that we need to be practicing. Then we need to actually go back to the books, check out the notes that have been written, check out the work that we did in class, check out the homework that we did, the corrections that we may have done as well when we were doing some of these questions that we were doing during the course of the year. Then check the questions that we were able to get wrong. Check the questions that we got wrong, and see what it is we were supposed to have learned. The lesson that we were supposed to have learned from the answers that we got wrong, do we still understand those lessons, and can we now apply them correctly in the questions that are going to come in the exam? Then also, do what needs to be done. So 3 to the power n plus 2, read to which equation, Zoe? This one, this equation. Okay, so like I said, okay, for 6.3.1, we were supposed to actually look at, first and foremost, we were supposed to look at what type of factorization does the question give us. So for instance, here with dots meaning difference means minus. This is difference. Of two squares, remember a square is a perfect square. So x squared is a perfect square. Okay, the square root of x squared is x. That's why it's called a perfect square, because when you take the square root of it, you actually get, 121. If you take the square root of 121, you will get 11. You get a natural number. Okay, so the square root of 121, the square root of x squared, you can be able to, and this is a difference. So basically what we do when we factorize in any situation with a difference of two squares question, you will open two brackets. All right, that's if there's no highest common factor first. Before you do anything with any type of factorization, always have to check, is there highest common factor? And yes, for this one, the highest common factor is 1. The 1 is there, guys. We don't see it, but it's there. There's a 1 there. It's there. You don't see it, but it's there. All right. So what we do then is we open two brackets. Then, since we know it's the difference of two perfect squares, I'm going to take the square root of x squared and get the answer. That's x. So that means I'm going to write x in the first bracket as my first term for both brackets. Then I'm going to go on and find the square root of the numerical value. Don't mind the negative sign, please. Just take the square root of the numerical value without its sign. So square root of 121 is 11. So that means my second term for each bracket will be 11. Then, what is the product of two signs that gives me a negative? It's plus times a minus. So therefore, that's why you have one bracket that's positive, the other one is negative. If you do FOIL on these two brackets, you will get x squared minus 121 back, which means this is accurate. Then you apply the zero product rule. What does the zero product rule say? It says if you have a product of two factors, they are equated to 0. You can take the respective factors, equate them to 0. So A is equal to 0 or B is equal to 0. So that's why, for instance, we took x plus 11 because this is one factor, and x minus 11, which is another factor. We took x plus 11, we equated to 0,
or we took x minus 11 is equal to 0. But remember, the condition says if the product is equal to 0, if it's equal to any other number, you can't do this thing of taking a factor, equating it to another number. No, it must be the factors, must there be a product of factors that's equated to 0. That's why it's called the zero product rule. So you take the factors respectively, equated them to 0, you solve, you get the answers for x. Okay, yeah, so this is grade 9 paper 1, guys. Okay, yeah. And Nuri, what's Nuri? What was the question from Nuri? I'm new here. When does usually go live? So guys, this is like I said, this is my 3rd time going live with a question paper. I did live sessions for grade 10 and 9 and 8 because the grade 10s here in the Eastern Cape were writing yesterday and they wrote. So I did a live for grade 10 yesterday. I did a live for grade 10 in the week. So when do I usually go live? So I had said to my audience that I'll start posting now on my TikTok page when it is I'll be going live, so that people know and they can expect when I'll be going live. I hope that makes sense. Yeah, so the time will come, but for now, like I said, I'm just going live up until 10 to, actually, yeah, I'll be stopping soon for grade 9, and then I'll go live for grade 8 at 1 p.m. Yeah, well. So let's just do this last one then, so that we can call it a night and a day. So 3 to the power n plus 2 is equal to 27. So this is an exponential equation, and exponential equations are informed by a property. If a to the power x is equal to a to the power y, the property says, then x is equal to y. So this is something that informs exponential equation. Yeah, so a to the power x, if a to the power x is equal to a to the power y, so in other words, when the bases on either side of the equation are the same, what this is saying is that if that is the case, if you can get this situation, what you do is you drop the bases and you simply equate the exponent. So it's almost as if the bases, they fall off, and then the x's, they fall down from their high horses on the ground, and you can equate them and solve. So in this situation that you can see, we have 3 to the power n plus 2 is equal to 27. Okay, what's beautiful is that 3 is a prime base. It's already in its simplest base form. 27 on the other hand is not. So what we do is we come here to this beautiful machine that you call a calculator, and if you don't know what the prime base what the prime base product expression is, you can do this and say 27 is equal to, all right, and then you go and press this beautiful button called shift, and then you go to this amazing button that has fact, and then boom, your calculator will give to you 3 to the power. So you just write 3 to the power n plus 2 is equal to 3 to the power 3. Does that make sense? Now what do you see, guys? The bases on either side of the equation are single and they are the same base. So the property can be applied. If a to the power x is equal to a to the power y, then drop the base and you can equate the exponent. So let's go. Let's equate the exponents. We can drop the bases. N plus 2 is equal to 3. We have allowance to do this. Why? Because the bases are the same. Then here we solve the linear equation. N is equal to, you transpose the 2, 3 minus 2, n is equal to 1. Simply put, on the dot, on the money. Thank you so much, Katlego. You are phenomenal. You are a star in the making. In fact, many of the people that have been responding here are just phenomenal. You guys are amazing. If you guys are fixing me like this, identifying my errors like this, some of you helping me out, see some of the things that I butchered, then I'd say there's a lot of hope. We can do very well. So please, guys, I think I'm definitely ending it here because I have to go. There's other things that need my attention at the moment. But hopefully this session has been helpful. Yeah, grade 9 paper that was written in Nelson Mandela district in the Eastern Cape I'll definitely be posting the paper very shortly, right? I'll upload it with a song so that you guys can actually file through it. Please also, guys, like I said, there's a maths what you might call. So on TikTok, I actually have the maths channel is Maths is a Game, because yeah, and the subscribers are still veritably low because I just started it, right? Yeah, Maths is a Game TikTok, right? It's still starting out, still relatively new, still relatively fresh. But yeah, so there I've posted only so far it's still grade 8 and 11, sort of like examples and certain things, certain topics. The topics are there. I've written for certain things that I've explained, but it's grade 8 and 11 that I've done so far. There's no grade 10 and there's no grade 9, because like I said, I literally started this was it last week or the week before that? Yes, I did. And I just started posting certain things that I thought were important to just start out. I think it has 60 followers, 60 plus, but I think you guys can populate that place, because as soon as that platform gets up and rolling, I can start doing lives exclusively there for maths. Because this platform I've been using even obviously for social and other things. It's like a personal account, and then also for other things. So I kind of want to split the two platforms. So if you guys can go on there and follow there about Maths is a Game. Maths is a Game. It has the TikTok icons with the topics and maybe some of the papers I've done. I did a grade 8 paper. I think I covered a grade 8 paper at some point, and I posted sort of like highlights of that grade 8 paper that I had done. And then there's some grade 11 there, like quadratic number patterns, but like a few things, man. It's not like, and it's quite probably 5 minutes, 6 minutes, some of the videos and all of that with explanations. Then with grade 9, I'm still gonna work on that. Grade 8 is there, but it will be updated. It will get better as time goes by. Yeah, what I do want for everyone on this platform to kind of understand is that maths is literally a game. I don't know if you guys have played a game and you were struggling to play the game in the beginning, but then what happens, the more you play the game and you get to know the rules and you kind of figure out how things are done, it becomes so easier. You get to a point where you master the game and it's just like so easy, and you like kill it, and you like, "Oh, I need another game to play," like it's because like this one is too easy for me. That's exactly the thing with maths. So you can't. So if some of you like were intrigued in your interest with mathematics simply because of the session that we just had, but this is like an isolated feeling you've had just in this moment today, all right, that just tells you that you have the capacity, you have the potential, you could have the interest to do maths and do very well. But the thing is, in order to sustain that, you need to practice mathematics. You need to do it over and over again. And even the things that you feel like you're comfortable with, right? Those things that you're comfortable with, they are higher order level type of questions for that very same thing that you feel comfortable with. So exposure is important. Practicing past papers is important. Asking your teacher for help and assistance when there's something that you don't understand is important. The little things, some of which I've highlighted when I was going through the session, are important. You can do so well in mathematics. Scoring 100% for maths is not something that is impossible. It's easy. I have a TikTok video that I posted of one of my learners in my school that literally, like, term 1 in grade 11, term 1 100%, term 2 100%. These are provincial papers he was writing. He just killed it, and he had an average for all 3 terms of 100%. That's feasible, and to have like more of you doing that, because remember, mathematics, your maths marks, if you do very well, they open opportunities. So please, guys, just give of yourself, give of your time, practice, and yeah, practice makes permanent. And you gain mastery, right? And that mastery is good, and it makes maths very fun. And when you are able to do that, then at least you stress less about maths, because maths tends to be so stressful for so many people. And the reason why that's the case is because people don't spend enough time being able to do it, and don't understand the basic concepts. You need to understand the concept. So important. So thank you so much for joining, guys. It was really good, and thank you for the follows. Thank you for the gifts. Those who were able to gift, like those who were able to help me attain and reach my life goal, I really appreciate it. Those who were able to really support in that, much appreciation to you for that. Hopefully, we can have more rich and more amazing sessions as time goes by. And yeah, thank you so much, guys. I mean, I think you guys were patient with me. Like I said, this is like the first time ever doing a grade 9 live session. I know that there were, McGinley's there and there, like Matata there and there, but yeah, I think we navigated the way quite nicely. So all the best. You guys practice well. Spend the time where you need to spend the time, and please don't feel like this is the only, and don't think these are the only questions that could possibly appear in your paper. There's so much more, right? So you need to then get exposure. Don't limit yourself. And thank you so much, guys. Thank you Nuri, thank you Odirile, thank you Katlejo, thank you Nuri, thank you guys, all the guys who commented. Thank you guys, Lati, Sid, CD, Tsitsi, and Ren. Yeah, everyone, man. Everyone that just was here and stuff. I may not have mentioned your name specifically, but you guys are phenomenal. So at 1 p.m. or slightly after 1 p.m., I'll do a grade 8 session for the grade 8's paper 1 as well, so that I can give them equal time. I know I promised them a session earlier on, but yeah, we'll do that. Thank you. Have a good one. Cheerio.